Look, I would bet you both my testicles the Earth is a globe.
3 coplanar points, and bam, there's the radius of the Earth.
On the level.
The way I phrase it is a monument to the curvature of the Earth. It really is.
Level.
It really is.
Level.
And bam, there's the radius of the Earth.
Look, I would bet you both my testicles the Earth is a globe.
Would you shut up? I told you that was the stupidest gosh darn thing I ever heard in my entire life. Would you shut up about that? You're making me look stupid, boy.
Look, I would bet you both my testicles the Earth is a globe, guys.
Whoa, 50.
Whoa,
50.
Whoa, my birthday, I use them a lot.
Wow, bro, let me tell you, you said it.
Now let's all get to the facts. The Earth is flat. You know it. I know it. Everybody knows it. Look outside, it's flat. Is it really that simple? Yeah, it's that simple. Imagine.
What is refraction? They don't even know. If they get it, they get something they don't know what it is.
Again, I think all of that's bullshit. It's all made up, right?
Was given to us. Refraction is an idea given us to us by the scientific community.
Which scientific community? QE?
Physics.
QE.
QE?
Yeah, who did you learn about refraction from?
Who did I learn from refraction from? It sure as hell wasn't quantum eraser.
Go on then. Who was it? Who taught you about refraction?
I don't remember their name. I don't.
Go on then.
Yeah.
What is refraction? What did they tell you about refraction? Just give us a quick, short rundown on it.
It's very simple, Bev. Light doesn't travel in straight lines always.
Light doesn't travel in straight lines, but light does travel in straight lines, right?
Not always.
Yeah, it does. That's the scientific community says that light travels in straight lines. So
no.
So somebody told you that light doesn't travel in straight lines, did they?
There's typical conditions and then there's exceptions, right? So in science class, typically you start with the general conditions, and then from there you extrapolate out and you look at more specific conditions.
Right? Was that you explaining what refraction was? Bending light, but not bending light, and extrapolating it out a bit more into something else, and then science says something brilliant. Yeah. Really, come on, 50. You can do better than that.
You start with the
QE's taught you more than that about it, surely.
You want to say
no.
Nathan Oakley? Give us a bit of what Nathan Oakley says. 50. What does...
I don't know. I haven't listened to Nathan Oakley in like 2 years.
Well, what does Zanuck? What does Zanuck say about it? Go on, what's Zanuck taught you about refraction?
I don't know. I haven't talked to...
Rumpus. Rumpus will have taught you something about refraction, wouldn't he? Come on.
No? Not really. I don't know.
Oh. So you don't even know what refraction is?
I've never heard anything new.
Wow.
The only thing I've heard new is maybe the classification.
Oh, well, so who did teach you about refraction then?
Huh?
Who did teach you about refraction?
I don't remember.
No. That's because you don't know anything about refraction. It's something that's been made up in these little corners that we all talk. And loads of people talk shite. And you, imagine that you know what they're talking about and you're with them because you're on their team. And they're talking brilliant and they're smashing the shit out of flat earthers. Because flat earthers don't understand what refraction is either. Because no fucker understands what it is. It's the truth.
Bev, I can turn on my camera and I can show you refraction.
No, you can show us looking through a camera. Looking through a camera
is not showing somebody. If you point the camera at the Statue of Liberty and go, look, that's refraction, I would go, no, that's the
That's
Statue
not
of
what I
Liberty.
would do. I would show you a laser bending.
You would show me a laser bending.
Yeah.
Go on then.
You would
How
show a
how
laser
do you
bending
show us
is what
that?
refraction is.
Would a laser bending be refraction to you, not just a laser bending, or appearing to bend even? I mean, I don't know. I mean,
Well,
what?
the definition of refraction. The definition of refraction is
Lasers
Oh,
bending.
please don't tell me you've just gone to a dictionary to find a definition for refraction rather than actually explaining what it is. You've gone to a definition.
No,
Right,
I
you
didn't go
realise
to a
that
dictionary.
definitions are meaningless
You
to
think
some
I have to
people,
go to a
right?
dictionary?
I'm saying
Oh,
to
yeah,
some
it doesn't
people,
matter. You just
definitions
prove
are
the Earth is flat.
meaningless.
Like Euclid.
There's a difference between a logical axiom and a definition. But before you get into that, refraction is just a word that people use to describe various effects that happen visually, right? Like you can't. There's miraging, like that kind of wavy stuff. Oh, just this refraction, just refraction. They just attribute everything to this word, like gravity.
Yay, there you go. That's a better, like, that's a really good meaning, right? Comparing it to gravity as in an encompassing one for all word that seems to have multiple meanings that can confuse people. People like you, 50. That's a pretty good way
I'm so confused by
of
gravity.
explaining refraction.
Well, you don't know what gravity is, bro. Like we'll ask you about. No, they'll tell you we don't know. We don't know what it is. We have no idea really what it is.
Yeah.
We just know what it does. It's the same thing, bro. You're just like you're telling me what you see. You know, I can see that.
Well, at the end of the day, you can ask why 1,000 times, but at the end of the road, there's no more whys. There's just is.
And what is refraction?
Refraction is light bending when it hits an atom and it reflects at a different angle than it came in at.
An
It's not
angle
law.
with it. Well, sorry, it bends and then it
Bouncing
hits
or
an
reflecting?
angle.
It hits an atom and it excites the atom, and then the atom releases energy at a certain angle that is proportional to the angle that the light hit the atom at.
Wow.
Oh, wow. So an object with no mass or matter hits an electron, then something
Atom.
energy, whatever that is, comes off at an angle, right? And then that angle that this thing came off of is your refraction.
Yeah, but that's an angle. Like an angle's a straight line, 50. Right? You said bending. Like, so, like, this is getting really more confusing and confusing, this. Refraction, what?
So
Well,
if
I mean,
something... where's the bend? I see a straight... even if I accept everything you say, you have a straight line to the atom and then a straight line out of the atom. Where's the bend? Where's the curve?
It would be an angle. I mean, if you're talking about true bend,
An
like
angle's
arc, it
not
wouldn't be an
curved.
arc.
An angle
It wouldn't
bend.
be
An
arc.
angle is two straight lines meeting, right?
Okay, well, I'm speaking colloquially.
Colloquially.
Like,
So
colloquial
you define
angle
words colloquially?
is curved. Nice.
I mean, give me a break. Like, you don't know what I fucking mean.
You don't know what you're talking about. That's the point.
A series of angles can create a curve.
Oh, no.
A series of angles, like a circle.
He's talking
Yeah,
about
like,
the Dornagon.
I was
We're like,
looking at
we've
how you
screwed
can-
them up with the Dornagon. Right? That's what you're talking about, 50, right?
How you calculate how you calculate pi, okay? What you do is you create an octagon, then you add another You add another
Dornagon.
arc
Yeah, called
segment,
it.
and then you add another one, and you add another one, and you add another one, and you add another one, until you get to the point where you have a curve.
Yeah, shout out to the Dornagon. It's all in
And
your
that's how
mind,
you can
right?
calculate pi.
It is all in your mind, this, isn't
Is
it?
this what are we still defining refraction? Are
I
you
think
still on
so.
refraction?
Yeah.
Yeah,
bunch
see,
of
you just made
angles
like a
can define
circle.
curve.
How
It's
did
not
you make a
perfect curve, but
circle?
you know what I mean.
No.
What?
No, like we were asking you
made a
about
circle at a
refraction and
90-degree
you've just
angle?
made a circle? Like, dude, you've got
Yeah,
a
I
model
guess it's over
in
your
your
head, my bad.
mind.
That was a little over your head. I'm sorry. Yeah, that was a little over your head. My bad. I'm speaking colloquially. I think I dare to say.
Do you know what
I dare to
colloquially
say that you
means?
know what I mean. Colloquially,
Yeah, do you know what that means?
right?
It's just
Like
a nice
typical,
word.
just general definitions that people use, not within specific fields, just in general usage.
Yeah, you've took
Right, so specific fields redefine words.
you've took a light ray,
Yeah, all the
right?
time, like hydrophobic.
Hydrophobic.
In physics redefines. Yeah, hydrophobic redefines phobic.
What?
How does it do that?
Happens all the time in physics.
Like scared of water.
It gives it a more specific definition.
A fear of
Yeah, that's what it
water.
means. That means that water is scared of the surface. No.
But is
It's
phobia and phobic the same word?
It's a version of the same word.
The water's scared.
Run and ran is the version of the same word, but it's not colloquially, right? You're trying to make one word two different things. Like because science is using up, it becomes down. That's kind of crazy, man.
It's virtually the same definition. Having an irrational fear. Phobia, phobic. Same definition.
Yeah, but a boot that I spray with hydrophobic spray, it doesn't have the fear of water. It's not hydrophobia. It has something different.
Yes.
No
yes.
colloquial redefinition.
That's exactly what I'm saying. Physics
No,
redefines.
that's exactly not what you're saying. There's
They
a
just
new word.
named
in
something.
that
You're
was
misunderstanding me. You're misunderstanding what I'm saying. If you're saying that, because physics redefines hydrophobic to mean that the surface water does not stick to the surface whatsoever.
It was hydrophobia was the word. They didn't change hydrophobia. They made a new word.
Is this not
Hydrophobic.
definition of semantics right here that you've
describe
purposely took us away from an argument or like a conversation, and you've just started talking about the definition of a completely different word in a completely unrelated context.
No, not at all. I'm sorry you can't follow along with the conversation.
No,
but you can describe somebody as being
listen, 50,
phobic.
what you were doing, you were in the process of showing us how a light ray that travels in a straight line, somehow related to refraction through you, turned into a circle. Right, so what you effectively did, you took a straight line, things that are known to be straight lines, and turned it into a circle. I don't think you even realised you did it.
Yeah, I did this last night. I was calculating pi using my computer to see how many digits I could get.
But you took a light ray, a straight line, and turned it into a circle.
And I made a curve.
Made a Dornagon. Yeah.
I took an angle and I made a curve.
And then you did something to do with an octagon.
Lines, dude.
Yeah, I took an angle, which is the relationship between two lines, and I made a curve.
How do you make a curve with two straight lines?
Within a margin of error. I can hold on, I'll show you a picture.
Margin of error.
Yeah, everything has a margin of error.
you have two straight lines and they intersect, making an angle. How are you getting a curve out of that? You bend it and then look at it from the top, so you can't see the bend. Then it's straight. Look, looming, another word for refraction. It's a type. It's refraction's type.
Did you see 50's flat Earth videos that he did? Right, the hand. He's
Okay, I'm back. I have a phone call.
He's turned flat earther. I think this is what he's doing at the minute. He's showing us now how little he actually knows about his globe model, and he's ready to accept the flat Earth now, right? Even you were even talking to your mama. Mama was saying, "Don't do it." I mean, like, you can't really join the flat Earth, and 50's definitely was in it. He had aeroplanes flying upside down. Proper flat earther, right?
How do planes fly upside down when down?
Hold on, wait. Can you get back to those two straight lines making an angle, then curve? It was like, there was like a magic trick. It was like, okay, draw a straight line. I was like, okay. Then draw another straight line and make an angle. Okay, no curve. And I'm like,
bam,
where?
How? Bam, margin of error.
You lost me.
Yeah, bam, margin of error.
Margin of error. It's gonna take me just a second, but I'll get it to you. Hold on.
Sweet.
Margin of error.
but it's all within a margin of error. And regardless, I told you I'm speaking colloquially.
Okay, so you're saying that there can be no straight line, because if you start getting in closer, it will be curved in some regard. So like margin of error wise, nothing's perfectly straight.
Yeah. In real life, there's no such thing as.
Okay, well, couldn't you say that like your curve has a margin of error, and if you get straight enough to your curve, it'll just be a straight line, so everything's straight?
Oh, see what I got today.
Not everything's straight. If you zoom in far enough, at that distance, it appears straight. But just like the Earth, we know that's not true. Things can appear locally straight or locally flat, but when you zoom out, they're a curve or they're a sphere. Look, I would bet you both my testicles the Earth is a globe, guys.
Whoa, 50.
Whoa,
50!
Whoa, my guy.
I use them a lot.
Wow, bro, let me tell you, you said it, right?
Yeah.
Now I'm going to say something. Now here's the problem with this world, and you don't even once you say something, you're tied to what you've said. You've now said that, okay? So let me tell you, you better start praying. My man, you better start praying for your testicles back and that you didn't mean that. There's going to come a time in your life you're going to lose them, and you're like, why the fuck did this happen to me? And I'm going to tell you, it's because
he might enjoy it, you know.
Words,
he might want it.
Sure.
You never know.
Okay, well, let me make one asterisk, okay? Unless we're in the Matrix.
What?
So if we live in real life, and this is truly
reality. This is reality. This is the only reality we know. 50. This is right.
That's the reality.
Okay.
Yeah.
Well, given that assumption, then there's no possible way the Earth is flat. There's no possible way.
You want to be open, so I like. You've not got any aspirations, you know, like hidden, right? For, you know, dressing up, putting a bit of makeup on, you know.
What?
Do you not?
Yeah, you're just saying nope. It's not gonna listen. It's a ball. Don't care.
No, I think 50 might have 50 might have aspirations, you know, for being a, you know, might be joining Brenda, right? This might be a way for you to actually make the step, right? But do the plunge.
Make the step.
Yeah.
Yeah, you find out the Earth is flat, and then you
Like you go,
transition over.
oh
to-
dear,
to both
I'm gonna have
flat
to
Earth
lose
and
me
your new.
balls now. Oh,
Bro, that ain't happening. That ain't happening. My testicles are staying on. It's not. There's no way. There's no way. I have a list of 25 things that are all perfectly in line with the Earth being a sphere. So, in order for that, for my testicles to be cut off, you'd have to knock off every single one of those.
No, see that you've just proven that to yourself,
yeah.
right? So like reality doesn't care that because you think on a flat plane something when it doesn't matter. So those 25 things are just things you tell yourself. That's it. It's just like comfort stuff
No, it's
you
not
tell
things
yourself.
it's logical deductions or logical inferences. It's just really simple things, like the distance between New York and LA is different if
That
the Earth
dude,
is
that's not
flat
logic.
versus the distance
That's not
That, no,
logic.
yeah, a measurement doesn't change based on the shape of the Earth. If I measure to the end of my block,
yes, it
doesn't
does.
matter what shape anybody thinks the Earth is. That measurement's always going to be the same. It's a measurement. So right, scratch one. Okay, you have 24 now. You get to use.
No, that's completely and utterly false.
Bro, you can't. So you're saying this is what you're saying. I measured a distance. Now, if the Earth was flat, that distance would not be like I measured it. So the Earth can't be flat. That's your argument.
No, that's not what I'm saying.
That's
Exactly
pretty
it. That's
bad.
25. Well, I can't
That's
wait,
poo
man.
with that.
You're. I'm wondering what he's
I'm
got taped
saying
up for the top 10.
Yeah,
that's not what I'm
dude,
saying. That's not what I'm
you
saying.
do.
I'm
He
not doing.
doesn't
We're not
want
doing the
this. You
measurement
don't want to
first.
keep
We're
doing this
doing
because if we knock 5 or 6 of these off, like fucking 1, 2, 3, he's gonna be like fucking feeling the pinch, right?
His balls are gonna start going. Shut the fuck up, bro.
Yeah, get
Well,
away,
let me
get
finish my
away.
point. So what you're doing there, what you're doing there is you're doing the measurement first. That's not what I'm doing in this scenario. What I'm doing in this scenario is saying that from New York to LA, if the Earth is a sphere, that distance is different than if the Earth is flat. So if you
How
travel
how,
that
No, okay.
distance,
how is that distance
so you do the
different?
measurement first.
How?
Bro, this.
How is that distance different?
Yeah,
Okay, how many distant in real life? How many distances are there between New York and San Francisco? How many distances?
Will there be one chord length
Okay, there's one exactly.
a chord length. Did you say?
on a sphere?
No. There's just one. Not on anything. There's just one on Earth. That's it. So it doesn't make a case for any shape.
Yes, it does.
No, it doesn't. It just makes a case for the distance between these two spots. That's
He
all
said.
you have.
He said
Is the
chord.
distance between two spots and nothing else.
He said chord.
Dude, you either don't understand what you're talking about or you're being disingenuous because this is just one of the most basic of basic things when it comes to
1,800
when
miles
it comes
between San
to
Francisco. Earth is a
the
ball.
flat Earth and the globe Earth. So if that's true, I think it's potato, then you should be able to come up with the flat Earth map so easily. And yet you guys
Okay.
don't have a
You,
flat
you
Earth
Oh.
map.
on. Can I? I'm gonna repeat your point. Tell me if I got it right. The distance between San Francisco and New York is 2,642 miles. Therefore, Earth is a ball.
The distance between New York and LA is 2,640 miles. If it's a chord length and the radius of the Earth is roughly 4,000 miles.
Chord.
Now,
No.
if you
Hold on. Whoa. Stop. I gotta stop you. All you had was that you start 25. You didn't bring up 25 with your. So your number 25. You said I have the distance between these two spots proves the ball. So you can't bring in anything else. So all you had was the distance between those two spots, and therefore you said it proved the ball. So I just read it back to you, the distance between San Francisco. But then when you read it back, you started adding more. You started adding the radius of this ball. So your 25 is irrelevant because you already have the Earth as a ball. Then all you do is apply your daily life to your beliefs. The sun rises in the west, therefore the Earth must be a ball. It sets in the west, therefore Earth
no,
must be a ball. There's 2,000 miles between San Francisco and New York, Earth must be a ball. We get February full moons, Earth must be a ball.
no, you're really not understanding this. Like if you travel, if you're a pilot or if you're a sea captain and you're traveling long distances and you need to know how much gas to put in your tank, you have to use a
Diesel.
chord length calculation to tell you how much gas you need to put in your boat or in your plane to tell you if you're going to get there. And if you're
This
wrong,
guy's got to
you're going
be
to fall out of
talking
the
like
sky or you're
fire.
going to be stuck at sea.
Okay, so
Now, since the Earth is
that
flat, hold on, I'm not
fuel
finished.
fuel is based on the distance, right?
Yes,
Okay, so what you have is the distance between 2 points, right?
but it's a calculation.
Oh, hold on, but hold on. The empirical thing you have tangible is the distance between 2 points that you've measured, right?
No, but no, we're
Okay, so
starting
you
with the
don't have the distance
calculation.
between 2 points.
No, you would get the distance at the end of the journey.
Okay, so how do you know how far the journey? Far do you know how far you're going unless you measured it?
You would measure it along the way.
On a
Okay, so
boat or a
you
plane?
measure. Okay, so you go on this journey. You measured it out. It's 1,800 miles. Now what?
Wait, say that again?
Okay, so you're going on this journey, right? We're walking, me and you, hand in hand. We go from New York to San Francisco. Me and you, we walked it. We had one of those little sticks that rolls, and we measured it. It's 2,200 miles. Now what?
Well, first, that's what I'm saying. First, you have to do it. You have to make a prediction first.
No,
You're missing a
what?
step.
No. Hold on, no. That's not
You're
real. The
missing a step.
prediction's in your mind. So that's you're doing things in
Yes,
your
the
head. So we
prediction is in
walked.
your
We
mind,
got 20.
correct?
Hold on, 2,200 miles from point A to point B. Without predictions, what did that journey that we just walked prove? What did it?
That calculation will give me a distance. The distance, I believe, is roughly uh, 2,640 miles.
So all
Okay?
you're doing right now is
I'm not
thinking,
finished.
right?
I'm not
You're
finished.
just
Yes.
thinking. Hold on. At this point,
So,
you're just
it's called a
thinking, right?
calculation.
But this is all happening in your head, right?
No, it's on paper.
Okay, but it's so you haven't done anything like you haven't measured anything in reality yet, right? It's all just theory in your head and writing scribble on paper, right?
Well, it's not. It's a
Hold on,
proven method.
bro, answer the question. As of right now, you did your calculations that you wrote down on paper. You've only done scribblings on paper and thoughts in your head, right? You haven't measured anything empirically.
Correct. Yes,
Okay.
that comes
So
in.
you're what you're telling me is that the empirical measurement is useless without your scribblings on the paper.
No.
Okay, so then do we need your scribblings
Wait.
on the
Say that
paper
again. Say
to
that
use
again.
the hold on, do we need your scribblings on the paper to use the empirical measurement?
You need to match my prediction to
What do you
real
mean?
world observation.
No, you didn't answer my question. Do I
One
need to
second.
use your scribbling on paper to use my empirical measurement?
What kind of question is that?
That's the one you're posing.
No, that's not the one I'm posing.
When
This
you
is going so
say
far over your head, bud.
you didn't make a prediction, when you say you didn't make a prediction before you made a measurement, you're asking me, why aren't you scribbling things on a piece of paper before you empirically measure that piece of wood? And I'm going, why the hell would I scribble things on a piece of paper before I measure this wood? Why don't I
Because
just measure the
that's what
wood
he's
so I
been
know
taught to
how
do.
long or far the distance is?
We're not talking about wood, and you
That's
still
well,
won't
no.
believe
Well, we're
where it
talking
is.
about measuring a distance. Why, if you're going to measure the distance from point A to point B, which is the same thing as measuring the distance from the start of the wood to where you want to cut it, why are you going to have a theory or a model of what that you're just going to measure the distance? Now, what you're doing is you're trying to create a belief system because you're in a religion, so
No,
that
I'm
you can
trying to
attribute.
use a scientific model to make a
No,
prediction
you
in
don't.
the real world.
We don't use
Bro, it's not that
scientific models to
complicated.
make measurements. To make
It's
measurements,
not
you
that
take in.
complicated, dude.
It's not. It's not a complicated. To measure a
It's not that
distance.
complicated,
Okay,
right?
so
So,
to measure a
listen,
distance, would you use a standardized measurement device or would you use a scientific theory?
in this scenario, what
No,
we're
no. In
doing.
any scenario, to measure a
Holy
distance, would
fuck,
you
me,
use
dude.
scientific theory or a standardized measurement unit with a device?
In measurement, to make a measurement, you use a measurement device.
Okay, congratulations. You're 24. Okay, so
Okay.
what?
So, what you still won't answer my question. You're so obfuscating. Can
There's
you
no
just answer
question to
my
answer.
question? Just answer my fucking question, for God's sake, dude. Okay. We're gonna travel from New York to LA. I'm gonna make a prediction based on a chord length of the sphere Earth. That chord length is going to give me a specific answer. And when we measure it out and see, and if we measure it out and we see that it matches, that it's exactly 2,640 feet,
Sorry,
that's pretty
wait,
good
whoa,
evidence
whoa, 50.
that
Okay,
Chord
so you
length.
guessed.
is it not?
Chord length. 50.
Is that not good evidence?
Chord
Right? If
length.
it's flat,
50.
if it's flat, it would be 50 miles short.
Chord length is what
Yes.
you are measuring on your model.
Chord length is what I calculated, and then we would, in my eyes, we would be measuring that chord length. In your eyes, we would be measuring a flat surface. But at the end of the day, when
50.
we traverse
50.
that
50. Do
that
you
actual
know?
distance,
Do you know what a chord is?
let me finish. It's a arc of a circle. It cuts through the center.
Yeah. You know, like a diameter. Like that's a chord, isn't it?
Oh, so
Yeah, it's part of a diameter.
It's the longest chord, isn't it?
So I actually did this.
50. 50. Just answer me this,
I
right?
actually did
A
this. I made a
diameter
video.
is the longest chord.
I can't believe you guys don't even
True.
understand this.
Is it?
What?
Is
What'd you
a
say?
diameter the longest chord?
Yes.
Okay. Now, if that's what you're measuring and you are traveling,
You could keep
do
going
you
around and
imagine
around again.
that you will have a direct relationship between a chord and a distance? Because you did just a minute ago. Now I've just told you that a diameter is in fact a chord. Do you think what you just said just before makes any sense at all?
I don't know what you're talking about. When I said
Were you
what?
measuring or calculating a chord length before to make a prediction for how far you were to travel on your model?
Yes,
Right,
that's
so
how that's
you
what
were
you do in
actually
science. You come up with a model, you make
traveling
a prediction,
along a
and
chord
then in
length.
reality, if the prediction matches what the model says, that's evidence that the model is correct.
Okay,
for the
but
chord.
I think what he's getting at is
It's really
so
not that complicated, guys.
a chord is a diameter. A
No,
diameter is
yeah.
of a circle, right?
A
Is
chord
not a
cuts
chord is a diameter,
through
but a chord
A,
can
cho-
be
the
a
any
chord
length
is
of a
part of
diameter.
the circle.
a chord cuts through
Yeah,
The
that's
the
gonna be
inside.
straight line.
Yeah. So if that's your prediction of how far you
what I said
travel
earlier.
and
That's
you're
no.
matching that, then you are not actually traveling on the circumference of the said circle. You are traveling along a straight line, which is called a chord. 50. Geometry.
Yeah, that's the point. You just measured a straight line, which can't be along the surface of a ball,
We're talking about a diameter.
which is a straight line.
A diameter is a straight line.
Yeah.
Is that news? Does a,
50.
I thought you guys didn't do that.
Go.
I thought you couldn't make straight lines on
50.
spheres.
Draw a diameter. I'll give you both my testicles if you can make the diameter of a circle not be a straight line. I'll put my testicles on that one.
One for each of the
You should go
radiuses.
away and
You
come
just said
back
it
when
was
you've
a straight
drunk
line.
less.
I mean, this is you
This
guys
is
are
great,
obfuscating like
Wow, bro,
mad.
that was
I mean,
that
this
was
isn't that
good.
complicated.
Yeah, you're
This
right.
is
It's
like
not complicated.
I can
You just
explain this.
drew a direct straight line with no bend or curve in it,
Let
and
me
that distance between San Francisco and New York. Congratulations.
Let me put this on
Welcome
speaker.
to Circular Flat Earth.
Hold on just a second. Let me put this on speaker, and I'm gonna ask this question to my 13-year-old. Let's see if she understands it.
Oh, don't do this again, 50.
Give me
Come on.
just a second. Let's see if she can understand it. I'm gonna see if my 13-year-old.
He put her under the heat last time.
You don't want to
Fucking-
look like
this
you're
is
stupid
nasty.
and you passed it on.
Don't do this to your kid.
Well, she's smart. I'm confident.
Wow, bro.
You're just gonna get her to parrot the same thing that got you laughed
I
at.
mean, this is the
you don't
most
want your child to
basic
get laughed at,
basic
bro.
shit when it comes to acknowledging scientific theories. You have a theory, you make a
Dude,
prediction,
it's
you
just
test it,
geometry.
and if it's right,
You're just
that's
talking
evidence
geometry
that
and
the theory is
measurements,
right.
not
It's not that
scientific.
fucking complicated. I have a
You don't
video.
gotta make
I
a
have
thesis.
video.
You don't need a thesis to measure the distance between 2 points. Okay, bro?
Then
Okay,
use
well,
geometry
whatever you
to
wanna call it,
work
okay?
that shit out,
It's-
And you
right?
call it a measurement.
Same principle, okay?
Oh,
Same principle. You
It's
can use
not-
different words if you want. I have one video on my channel where I analyze the distance between of common flights
That's one too many.
between using a globe and using common maps, and the accuracy of
Dude,
the distance
you're
on
down
the
to
globe
24.
is 99.9% accurate. Oh shit, my push to talk fucked up. Now on my map, I made a globe model in CAD, and I used common flight routes and their distances. And the globe model was 99.9. The globe model was 99.9% accurate. And I used the Gleason map. I used 4. And those other maps were off by anywhere from a factor. The Gleason map was off by a factor of 50% in some cases. The other ones were off anywhere from 10 to 20 to 30%. Now you tell me what's more accurate.
Okay,
in that
so what you
scenario.
do? Okay, so you compared your belief to some other beliefs. The other beliefs didn't match, so your belief is right. Congratulations, that's how religion works.
I compared math and distances.
No,
You tell me
I
what
tried.
religion you know that uses math and calculations and distances and
Yeah, those are
trigonometry.
that's science. That's the religion of science. Math, because math is
Oh,
just
yeah.
functions in. Hold on,
Yeah, the
math
religion of science.
math just functions in your head, right? Math is not in
Math
reality. It's just in your.
Math,
Can you
math
show?
is a discovery.
Wait, where did you discover math? Under a rock? Was it inside a tree? Where was
From
math?
from the real world.
Where in the real world was math discovered?
Well, if I hold an object and I drop it, I discovered that it falls at a rate of 9.8 meters.
So dropping a rock
Pretty
and
simple,
watching
right?
it fall. So if I drop a rock and watch it fall, that's math.
You can create
I
a
discovered.
mathematical
I
model.
discovered.
You discovered a principle of math. You can
So
write an
so
equation
when I watch
based
something
on that.
fall, so watching something
Hang on,
fall,
hang
I
on,
discovered
stop,
math.
stop. No,
Yeah,
he said
yeah, you absolutely.
no. You guys let him
You
say
absolutely
it
did.
falls at a rate of 9.8 meters per second per second. Where do you see that happening?
Everywhere. What was that question?
Where? Yeah, that
in-
only happens in a vacuum chamber.
No. You want me to film it right
What
now?
happens when I drop a helium balloon?
That's a man-made object.
Yep. But what happens when I drop it?
A helium balloon?
Yeah.
Well, that's a man-made engineered object, so it would float up because it was engineered to float up.
So when I'm staring at a rock just sitting on the ground, it ain't falling either at 9.8 meters per second.
No, because something's holding it up.
How'd it get up there?
How to get up where? Where you held it?
Well, it's got to fall, right?
What?
It has to fall, right? It has to be brought up to a spot to fall from.
Well, I
Hang on,
mean,
I got a train that's about to blow its horn, so I gotta go on mute.
what about the grand?
Falling isn't math though, right? Falling's not math. Falling is falling. So a rock falling can't be a rock falling and math.
A math describes the rock falling.
Yeah, language. Language describes, yes. We agree. We can describe what is happening with words. Right?
And math. We
No,
discovered
math is
the
words. Math is words. So
Math
is, and this is,
words.
you're trying to, hold on.
Math is
You're
numbers.
trying to make, wait, yeah, numbers, one is a number in English too. Math is a language, just like English. It's spoken word, okay? It doesn't separate itself. It's just spoken word.
It's
Okay,
spoken,
hold on. That's all I need. That's all I need. That's all we need. That's all we need. So math is no different than English.
way different than English, way more precise.
Oh, what do you mean precise? So what does that mean? More
You
precise.
don't know what I mean by precise.
So
really,
is ONE is that pretty precise to describe how many things are there?
Yeah, but you're taking.
Oh, okay,
yeah.
okay. So can I say every? Okay, yeah. So can I say every word in math in English?
I'm not so sure if you can or not.
Okay, so is square root, is that English or math? When I say the word square root, what language is that?
What if
Math
I wanted
or English?
French?
Well, that's English. It comes from math.
Okay. So hang on. So I could say the square root of 64 is 8. Would that be math or English language? Which language did I just speak?
Well, the math came first.
No, whoa, no. You didn't answer my question. Hold on. This sentence. Listen to the sentence I say right now. The sentence I say right now. Which language is it? The square root of 64 is 8. What language was that?
It's English.
Okay, was that pretty precise?
Yes, because it's defined.
Okay, that's great. So English can be pretty precise because it's a language, and that's the purpose of language, right? To be precise.
Because you're using mathematical terms.
No, you just said it was English.
Mathematical terms, dude.
No. Oh, wait, but you said so. Wait, math was a language.
Dude, are you not aware that
maybe you're not aware.
That is one of the
maybe
biggest conundrums. Hold on just a second. That is one of the biggest issues in the world is the fact that language is ambiguous. And people don't understand what people say. It can be interpreted in many different ways. If you're talking about
same with math.
Mathematical terms, I'm not done. If you're talking
interpreted
about
many different ways,
mathematical terms that are defined specifically,
English words are defined specifically. So math is no different. Math is no different. It's no different than any other language, man. It's no different than any other language.
You're fooling yourself if you think that's
You're
true.
fooling yourself to think that one language can separate itself from all the others and explain the world better when it's nothing but people looking at the world and creating a language to describe it. It doesn't matter if that when they look at the world and they create a language called English or where they look at the world and create a language called math. It doesn't matter. It's all stemming from the exact same source of information, which is a human being looking at the world and creating symbols and mouth sounds to describe it. None will ever separate themselves as the foundational volcano of information. It's just describing what we see. Nothing more, nothing less.
Yeah, but we're talking about something extremely precise.
So he agrees with everything I say. Yeah. Then he goes, but I'm going to do. But. Okay, hold on. Don't remove anything. You said but. Hold on. Let's go slow. Wait. Slow down. Let's go slow.
Right hand. You've got to slow down with him, right? You've got 50s.
I have been. He's not letting me speak.
We got to go back. Let's go back.
Yeah, 50's had a few drinks. You've got to.
Math is a language.
Don't go too fast with him. Slow down.
I've had a couple. So we'll go slow here. So math and English are what humans speak to describe the world, right?
What? Say that again.
Would you agree that math and English are sounds that come out of our mouth to describe the world?
Sure.
Okay, so they're both. So when you describe the world through your mouth sounds, it doesn't matter what sounds you make. You're going to be doing the same thing, right?
Well, one is vague and the other's precise.
Okay, right. Well, here then.
But
Just a
they're-
minute. Can I let
okay,
me come in
how
here?
can-
Right
okay,
hand. Let me just come in for 1 second here. Right. You're talking about
Go for it.
maths and all of this English and all of that. Now 50. You're saying one's more precise than the other, right? Now, English is what we use to be able to describe things, right? Now, you say one is really exact and the other one is, like just words and shit. But we use the words of one to describe the other. I'll give it to you. Just give us a quick one. Describe one for us within your maths, right? Go on. It's the start of your
Describe
mathematics.
One within maths.
Yeah, go on. Describe one, please.
A singular item.
A singular
A
item.
quantity of a singular item. Yes.
Okay.
It's an abstract. You can use language in all different kinds of ways, and you can use it in vague ways, and you can use it in precise ways. In mathematics, there's a lot of thought put into how we describe things using English to make sure that there's no ambiguity.
Okay, so you're saying one is a singular item, right?
And
so
even then, there is
what
still
is
some ambiguity.
what is one singular item added to another singular item then? Because I don't think you can you?
Two singular items.
Okay, two singular
That would be
items. So
two items.
no, that's two items, right? Are they not singular at the point you add them?
Well, I mean, they're singular. Yeah, they're two singular items, but as a conglomerate, they're two.
Okay, so
So cow. We have two singular cows, but as a conglomeration, they're two.
right, so they cease to become one
I have two tests
at the point that you
right?
make more than one, but one of them is singular. One is singular. So how do you get another singular to add to your initial singular? Because it is singular. So how do you get another one of them if it's singular?
How do you get another? Well, it's just all about, right?
It's all about what?
Here we're talking about cows. We're talking about, like, just say cows, for example.
Yeah.
We have 3 cows.
Yeah.
Each is a singular entity.
Yeah.
You can group them.
So they're always going to be three singular cows, right? You can't add them together to make.
Correct.
Can you? That's not possible, right? So your maths is falling into pieces when you come to try and explain it in reality, right?
Say that again?
You want to add a singular item to another singular item to make something different, but you can't because you've got a singular item.
Not necessarily.
What do you mean?
Why you think I want to add one singular item to another singular item to create something totally different?
Okay, well, is 2 different than 1?
Yes, 2 is different than 1.
Okay, so how do you get singular 1 and add it to singular 1 and come up with something that isn't singular 1? Like you said, with your cow.
Evolution, bro.
categorization.
Basically, 50, right? We have to live by rules. Mathematics is governed by those rules.
Yes.
Right, so
Correct.
you have to come to an understanding of the said rules. So you don't even know what one is. Nobody knows what it is. It's undefinable.
What?
It's
What
a
is undefined?
mathematical concept. You've been told 1 and 1 is 2.
No.
One is not
Numbers are abstract concepts we apply.
One is a subjective term. It's very subjective. You can have
Subjective?
1 pound of sand, or you can have 1 grain of sand. One is a subjective description, not an empirical truth.
Yeah, but that's a definitional thing. That's totally you're flipping it on its head. That's not.
But that's what one is. One is not a thing in reality. You can't hold one.
No, it's not a thing
You
in
can hold
reality. You're correct.
you can hold a rock, and then you can say you can apply the concept of one to that rock, but you're not
Yes.
holding one. So you
Correct.
can't. That's what exactly. So one is a subjective description of an objective reality,
I
like
don't know
all
if
math.
it's well, I guess it is kind of subjective if you're
It,
talking
it
about
is. It is, dude.
definitional.
And so is math. And that's why math actually isn't as great because it's a language like any other, but it can be very subjective when you say you have one thing. You need more.
Yeah, but you can be precise and you can make it extremely precise.
But you can do that with English. And the whole idea is you're trying to say that the thing that makes math precise is the empirical nature of 1 and 2, when you then just agreed that it's a subjective nature of the numbers, which would then not be precise.
It's still precise.
It's a subjective description is not precise. The objective reality is precise.
Well, it depends on your definition, right? If we're talking about rocks, then it's objective. One rock, it's objective, right? Anybody in the world, no matter who it is, no matter what it is, one rock is one rock because of the definition of a rock. Now, if you're talking about
Which one though? Which one?
Which one? What?
Rock.
Any rock, any one rock, just one rock. If you're talking about something that's
all of the individual rocks are one rock.
No, that's not.
So
there you go. See
one
how
isn't
you
the
see
same.
right there.
What?
One isn't a uniform thing, is it not? You said it was very exact.
Are you not seeing how not exact it is? Are you not seeing how you're constantly having to explain math because it's not as exact? When he said, does one rock mean all of the individual rocks? You're like, no. Because when you say one rock, which your math, it's not as precise as you're making it seem because one is the subjective description. This is what we're trying to show you with all these different things we're saying.
Yeah, look, there's no perfect system, and you have to define what you're talking about.
So you agree that math is not a perfect system and it's not precise. That's what we're trying to say. Math is no different than English.
It can be extremely precise. You just have to define.
So can English. English can be extremely precise. No language, every language, they can all be extremely precise. No language separates itself from any other.
So let me ask you this: how come engineers and physicists and chemists don't go to university to learn English?
Oh, come on, man.
It would seem that math is a little bit more precise, right?
It's not precise. It's nobody learns math, right? Math is a language. I'll give you that. Nobody learns math as a baby. You have to learn. It takes a long time to learn a language, especially when it's not your first language. So why do they go to school for many years? To learn a new language. It takes a long time to learn a new language. This is why it takes so long to study math, because you literally have to learn a new language. But
yes,
that new language is no different than the one you already knew. because I could describe the world in the exact same capacity with English as I can with math. Because
No, you can't.
because the only difference that math separates itself from English is when you write it down. Math has symbols where English only has words. So every symbol in math has an English equivalent word, allowing English to be just as precise as math can ever be.
That seems just so
And that's
ridiculously
absolutely
untrue.
true. No.
Whenever you talk about engineers and scientists and physicists, they use math because there is no mechanism in English to provide the specificity required to describe these complicated systems. You have to use math. There's no other way.
Does
There, if there was
does
another way,
every
go ahead.
let me show you out. Does every symbol in math have an English equivalent to describe it?
Yes.
Okay, so every symbol in math can be used and described in English. So English can use every symbol that math uses. So English can be just as precise as math, right?
Math
Or
it's a different language.
24 you have now. You have 24.
Hold on.
This
I
guy's
mean,
he's looking at his nuts like they're the end of days, bro. The last of the
no,
Mohicans.
I mean, you got a point. You can't talk about math in terms of you can use English to
I
talk
know,
about
of course.
math, but you can't write down an equation in English, buddy.
Yeah, you can. Okay,
You
hold
can't
on, but hold
you
on.
can't
But hold on,
program.
hang on. Okay, so now your argument has changed a little bit. So now it's not that math is more precise, it's just that you can write math down. So
You can
24
write English down.
or 24 and a half. We'll give them 24 and a half.
Do what? Say that again.
You got 20. We'll give you 24 and a half proofs.
Like for instance, right? Your computer, the way it operates uses binary. Your computer cannot operate using English. It's not possible.
But what is binary?
It has
0
to
and
have
1.
mathematics. Yes,
Binary is
binary is
0 and
zeros and
1.
ones.
Yeah, 0 and 1 is in English, can be described perfectly in English. Very precisely, actually.
Yeah, but
So,
it
again,
cannot be used. It cannot be
you can
used to
use
perform.
English. Instead of putting the circle and the 1, you can code with 0 the word. It would just take longer, right? But you can use you can use different symbols to code the exact same stuff. Don't be stupid. Come on. So English is
I don't
just
believe
as
you can.
good. English is just as good at describing precisely the world. I know. That's why this is why we describe the world so eloquently with English.
Okay, you show me a computer program that's written in English or a
Yeah,
mathematical
have
equation
you
that's
ever
written
read
in
computer
English.
code? Have you ever
Yes,
read computer code?
yes.
That's English, right? There you go. What
No,
runs? What
that's the
This guy just said, "Show me something running on computer in English." I showed him the actual code that runs
you
computer
didn't
in
show
English.
me code.
Bro, what is if then? Right? Like
You're talking about the operations. I'm talking about the underlying code that performs those operations.
yeah, that's you can write that, bro. Symbols,
It
right? Would you
uses math.
agree that?
It
Hold on,
takes
would you
you
agree that code is symbols?
code is symbols, code is math.
No, hold on, hold on. So when you write code, you're putting in symbols, right?
Mathematical symbols.
No, I'm not. No, I don't. You don't. They're just symbols. You can apply whatever word, but it's a symbol, right?
Sure.
Okay, so it doesn't matter what thing you apply to that symbol. The symbol could be in English, it can be in French. Doesn't matter. You just write it with a symbol. A symbol's a symbol.
Okay.
Okay, so there you go. You use symbols.
So can you show me an equation in English?
Symbols?
Show me an
Yeah.
equation in English.
One plus one. 1 + 1 = 2. That's English. That's an equation.
The most basic of basic equations.
Okay, how about I'll give you a more complicated one in English. The square root of 64 times the square root of 258 minus the smallest prime number. You know, look, bro, you're just
How about this? How about
you're
this?
fighting the truth here, bro.
How about this? 10 divided by 5. Write that out for me in English.
Yeah, TenDividEByFive. There you go. It's all done in just
That's
word sounds, bro. This is all sounds from the
Wow.
mouth.
that's not giving me the information that the mathematical counterpart would give me.
No,
You're
but
leaving out a lot of
information, bro.
information.
Information is conveyed through symbols and mouth sounds, right? So no symbol and mouth sound can convey information any better than the other ones because they're all the same, symbols and mouth sounds.
You cannot crunch
Are
computer.
all okay, but you're avoiding everything I say. Is every language symbols and mouth sounds?
Wait, yeah, you're in the home. Give me just 1 second. I'll be right back.
Putting pressure on him. Right in the hand.
I mean, I just think it's all mouth sounds and symbols. One's not better than the other.
He's struggling to come to terms with being a flat earther, right? At the minute 50, he's going through that struggle, right? Try and ease him through. We can bring him over. He's just he's in that confusion part, right? That his brain's trying to work all of this shit out. I mean, he's not stupid. And he obviously knows there's some problems there. Mind you, saying that he did offer his nuts up, didn't he, earlier?
Man, that you would never. I mean, like I felt confident offering my nuts on diameter.
Yeah, well, yeah.
That's that's established. That's what a diameter is, right? Like you cannot change the fun and.
Yeah. You never know, though.
Your argument will always trump the optical one because the optical one is a debatable factor on what you see, whereas if you have established the line that is horizontal, there's no debating that from there.
Yeah, you do realise, though, that like things like that to us, right? When you're talking about the diameter of a circle being a straight line, right? It has to be because it's defined as such, right? Within the rules of geometry, right? But there are people out there that would be willing to just fancy free make up a imaginometry type geometry, right? Say that geometry that you're using that defines the diameter of a circle as being a straight line into something completely new that they've just made up, and they'd tell you that like you'd have to hand over your nuts because they've literally just made up a geometry in their head where a diameter of circle isn't a straight line, and that, like we see it all day every day.
That's why you got to start with the and they used to get on me, right? Because I would argue definitions. Because I'm like, look, and it's basically what you're doing. Like, look, we're not really. What's the point of moving forward if when I say straight, we both think of two different things?
Yeah, man. That's what we're here doing. We've got to establish the baseline first to start off with, and if it's straight, it's straight. If it's curved, it's curved. But we've got to have an agreement what the fuck it is. Geometry states that it's a straight line.
Yeah, and even logically, you would, you have to have the straight to know the curve, right?
Yeah.
Because curve is deviating from straight. So you gotta start with. You can't deviate from curve, right? Because a curve can be. There's no uniformity to curve. Curve can be of any. You can have a wavy curve. You can have an irregular curve, but a straight is a standard which you can compare to. This is why we use it.
Yeah, you need the straight to find the deviance from the straight. And also, I would say, even more basic than that, a curve is can only be described as a distance from the center of a circle, right? That's what a curve is. It's the distance from a radius. And that radius has to be a straight line. Otherwise, you can't describe a circle, which is the only way that you can effectively describe a curve, is with that radius length.
Yeah, they're trying to. They would like to cut out the straight line part and just use the. We can. Even though you need a straight line to make a curve, we're just going to live in a world where we don't have the straight line, but we still have curves.
Yeah, but it's one of those things that, like define one, define that, and like you ask people to define a curve, they can't do it. How do you define a curve? Well, to them, or anyone, like especially in this fucking arena that you're talking to somebody, they don't know how to describe a curve, and yet they will tell you 8 inch per mile squared. Right?
That's compared to a horizontal.
I know, but that to them, right? That is a curve, right? But it's not. It's just a fucking number and some things, right? It doesn't mean anything. It doesn't actually describe a curve. It's just a number that somebody's given you as a calculation for some sort of mathematical thing for people to do some Pythagorean theorem of geometry to measure something when you're just doing circles.
Not measuring anything.
You're just fucking doing geometry of a circle by using Pythagorean triangles around the edge. It's crazy.
And then converting that into some 3-dimensional object somehow.
Yeah. And then saying, look, this is what we don't see.
Bro, that when he started using chords, and then you're like, yo, you realize a chord's a straight line that doesn't deviate. It was just like, oh.
Through the centre. I mean, we're due for Gently. Gently should be coming round. Because he's going to tell us he's imagining. Because he imagines the horizon is a chord. I'm waiting for that. I need somebody to teach me how to imagine the horizon as a chord. But I mean, obviously, there's something going on within the minds of people like 50 and Gently. The chord function is coming into the geometry, right? Like somebody's going round explaining to these people how they explain something, and they're using a chord in order to do it. But then what these people are doing is they're coming away and they're freestyling this new geometrical thing that they've been taught using a chord, and imagining some fantastic things. Like 50 imagines it being the flight path, and he matches his distances along that chord length. And Gently imagines that chord as being the horizon, the one that he sees, or apparently sees. And obviously Jesse Kozlowski measures the hump, or the sagitta, from that chord at the highest distance, obviously. How you measure the hump of the water level. So there's many effective ways that they do use the geometry of circles. Chords. I mean, old school was tangents, wasn't it? They seem to have lost that tangent just recently. It's gone beyond. It's gone deep into the circle now, and they're now using chords. So keep an eye out for it.
It's amazing, man.
Yeah.
Like when you start breaking down what they say, you're like, wait, you measured the circumference or like part of the circumference, right, of a circle, which would be the surface of a sphere, with a straight diameter. That's amazing.
Yeah, well, it's not necessarily a diameter. I was just using a diameter as a, because that's what a chord is.
Well, yeah, but it's
a
a straight.
cut
It's a
through
straight.
the
Yeah, it's
center
straight.
of the circle. Yeah, it's a
It
straight
never
line.
curves.
No.
You never curve a chord. You're never gonna like start
And
veering off to the left.
if you were to travel of the arc, in between those 2 points, it would always be a greater distance than that measured on the chord. But I mean, 50. Hats off to you. I mean, like, you definitely had that straight line distance, didn't you, as being your verifier. So that would necessarily state that you were definitely not going along an arc on when you were traveling. So yeah, you debunked yourself with that 150. I mean, like, that was it. That was an easy win.
Wait, how did I debunk myself?
Because you had the chord as your distance marker. Well, that proved that you didn't travel along the arc, because the arc would have been a greater distance. And you said you didn't do that. You had the chord as your distance marker, and that was a straight line, not
Didn't you count
a
your
curve.
elevation height into your curve?
Well, that's another one, right? Because it would have gone even further, wouldn't he, if it had gone over the curve?
Yeah, I calculated this. I have a video. I'll post it in chat. And the chord length is longer than the flat Earth length. And whenever I flew, I charted the data.
What are you? No, wait a minute, 50. Are you assuming here, right, that the flat Earth length would be the arc?
No, the flat.
You cut out then.
The flat Earth length would be if I travel over a flat surface.
Yeah.
So that'd be like a straight line.
And what's the chord?
Like across, just like a table, like a kitchen table.
Yeah.
The chord length would be if, like, you imagine like a big basketball. And the difference between the chord length and the straight length from New York to LA is the difference is about 50 miles. It's 50 miles shorter. If it was on flat Earth, it would be 50 miles shorter.
Yeah. Like, well, I don't want to correct you or anything, but you do realise that a chord is a straight line.
A chord is
a straight line.
A chord is a straight line on the surface of a sphere.
No, a chord is a straight line.
Let me look this up. Let me see if I'm.
Circles are different, buddy. You're using a term that is describing something on a circle, which would be a straight line on a flat, two-dimensional object. So you're using a straight, direct path.
Do you want me to? I'll just do a quick search for you, because it seems like you're a bit incapable. But what I'll do is I'll just go on to Google. This is like this new device we've found. We keep getting told about it, right? And I will put in CHORD chord and press enter. Chord music. No, not really music. Geometry. Wikipedia. Here we go. That sounds a bit better. Okay, now I'll just get this little screenshot for you. Right now.
This means school is in session.
Yeah. This is just a little bit of geometry. I like this. This is what we
I'm
do.
talking about
and debate discussion.
It'll be a great circle route.
Right.
Almost there.
See that there?
Almost there.
There you go. 50. Have a look. Debate discussion.
So S.
And as you
room 101.
Debate discussion. It says there the red segment BX is a chord, as is the diameter segment A.
Okay, he's
B.
wrong. He's wrong. 24.
Yeah.
Yeah, I'm not perfect. I'm more than happy to admit.
Okay, 24.
24 proofs.
Let's go that one.
That's kind of how you know I'm not a dipshit, right? And I'm
Okay.
not religious dogma. If I'm wrong, I'm wrong, and I'm talking about what would be considered a great circle Vertical root.
Oh, you mean you didn't mean chord? Yeah, so you
No,
did mean
S.
chord.
Look in the chat. Look in the same chat. S is what I'm talking about.
Oh, that's the arc. I could have sworn I asked you at the beginning whether you meant arc or chord, and you said chord. And I got you to confirm it, and you were definitely sure that you did say chord many times.
Oh, I thought that was the proper term.
No, chord is the straight line. We did say that a few times as well, I think. Did you not hear us, or did you just
know you're
not?
wrong.
Yeah,
So I kind of assumed you're wrong.
yeah. You do all that quite a lot, right? You seem to assume that we are the ones that don't know anything about this shit.
That was your fallacy.
Let me double check this. Hold on.
Seems like you're still having to double check this. It seems like you are not coming into these conversations being honest.
Yeah, I was wrong. Yeah, okay. So what? Big fucking deal.
Okay. Now,
I mean, that shows that I'm human.
yeah.
No. If you were honest, that would show you're human.
And I just showed that I was honest.
Right, so you know how
Yeah,
long
but
it took us to do that and for us to go through that? Was that mainly because you just didn't trust what we were saying, or you just didn't believe what we were saying, or you just thought you were correct? Like, cause
I'm sorry, say that again. My daughter was talking to me.
did you just assume you were correct, or did you assume that we were obviously wrong? Which one of those two do you think was the biggest factor? And then, you know, when you actually turned back, was that when I went to Google and got the picture? Is that what eventually was that the deciding factor that you were actually wrong?
Why were we doing a play-by-play of something that happened minutes ago, Bev?
Well, I know. I want to go over it because it will help me in the future, right? For me to understand.
I put weight in references.
From Google.
Yeah, mathematical references from Google, yes.
Okay, that was the
and if you know
deciding
Google,
factor.
Right, you can get some shit references from Google, but I mean, and if we're talking about mathematics, unless it's a really complex subject, the main stuff you get from math from Google is going to be okay.
Discernment, right?
What?
You'd use some discernment, right?
Yeah.
You know what the word discernment means, right? Yeah. We try to use that around here. Some proper discernment.
Do you?
That's a good word, that, Rob. I quite like that.
So let's get back to this distance. This distance between New York and San Francisco. Now, do we measure distances in the shortest distance between 2 points?
You can measure distance in many different ways.
So, if I was going to measure a board, you know, like the distance from point A to point B, would I measure the shortest distance between those 2 points?
Straight board?
No, like I'm measuring a distance between 2 points. Do I use the shortest distance, or do I walk around a little bit?
Well, I mean, you need a little bit more context.
I don't. You. What more context do you need? When you measure
the context
between
is
2 points, how do you do that?
2 points on like on your model. That's all you've got is 2 points, right? The shortest distance between those 2 points. Now, is that BX, the red line, or BX, the arc the black line, the one that's part of the circle, the circumference of the circle.
Well, in yours, BX would be the shortest distance between B and X would be a straight line between B and X. I don't
So
know
the
why we're
red
going over
one
such
then,
basic shit.
the red one.
Yes.
Okay, so you wouldn't have the other one. Would you say the one with the arc is a longer distance?
1 second.
Is it a longer distance than the measured shortest distance between 2 points?
Say that again.
Is the red line, right, BX, the shorter distance, but BX, the black line, is that your distance, or is the red one your distance? Which is the shortest distance between B and X?
We just talked about this. If there's no constraints, meaning you can move anywhere on that surface, it's just a straight line between B and X. I don't know why we're going over such simple stuff.
Which is the straight line is what I'm asking you. Is it the red one or is it the black one?
Yes. Well, they all look straight to me, besides the circles that inscribing them.
And we're talking about BX. There's only 2 lines that join BX, isn't there? There's one red one, one black one.
Yes. They all look straight to me.
What, the black
What?
one?
Yes, B and the line between B and X, the red one, looks straight. And I think you said the line between X and M, or X and
No,
B and
B
M.
and X, the black line.
I only see a red line.
The circumference
Oh,
of
no,
the
you're
circle.
talking about the arc?
Yeah.
Oh, yeah. I mean, if you implement a constraint, and that constraint is you have to move along the surface of the circle, then yes, the shortest distance between B and X would be that arc length.
Would that turn that arc length into a straight line? Obviously, just in your imagination, right?
I'm not. I'm just saying. For the sake of making this easier.
I don't know. You broke up then for me. I don't know whether it was like that for everybody.
What was the question? What was the question?
I said,
Is the-
if
is
you
the arc
put
length
that
correct?
within your constraints, does that make that line an arc into a straight line?
No.
No. And that would be because?
Well, because it's a radius. We're defining a radius.
No.
That'd be the definition of a curve, essentially, in this system. Hold on just a second.
What the like a
I might
radius
not be
was
able to
the
respond for a
definition
second.
of a curve? I don't know.
It's a neat little magic trick they do.
Mm.
You get a number, and then say, "Oh, this number is a curve," and then the circle, and then the straight line, and then the straight line is different.
Yeah, a
So
straight
much
line. If we can
mumbo-jumbo.
define a straight line around the circumference of a circle, then that's what we need to do. Therefore, that then becomes a straight line. That's what I've always heard in the past. And I could have sworn 50 was saying something about a great circle.
Yeah, because how are you going to know if, okay, let's say you walked, right? You went from B to X. Okay? 1,500 is whatever, is your unit measurement. How do you know if you walked the red line or the black line? I mean, even if you get it, it makes no sense.
It's just a distance. Right?
There's no comparison.
How how do you tell the difference? You measure the distance that you walk.
But here,
Or
okay,
travel.
okay. Let's say there's point B and X. Okay, you see on the one that Bev's A, M, B, X with the red line and the black line. Now we walked from B to X. The distance was 1,200. How do you know if we walked the red line or the black line?
Because you could calculate the distance.
Calculate?
That
You've just measured it.
Yeah, you could calculate the distance between.
But
B
you've
and
just
X and
measured it, dude.
We don't need to calculate it. We already measured it. It's 1,200.
Hold on just a second. Y'all can talk for a
Oh
second.
my
But I'll
God,
be back
bro!
in like
Where is
60
he's going to
seconds.
get help?
Yeah.
Tell me,
I'll be back.
he's
Yeah.
going into the big room of ballers.
My daughter or something.
Okay, where's-
Give me like
where's
60
my
seconds, I
help?
can still hear y'all talk.
Where's your help? Go on. On the other PC.
Bro, he said we measure it. We did already. We
I
already
think
just measured it. You can't
he's-
measure it again.
He might be calling on the help of his 13-year-old daughter to come and help him out here. He's stumped.
Bro, that's more likely.
Stumped. Ruhif did this yesterday, right? When we were doing this, he had his angle, right? And then you measured the angle, and you went, "What do we do with that?" And he went, "Well, now we will predict." And it's basically exactly what he's just said. We're going to calculate something. Like, calculate what? The distance that you've just measured. Well, that's what Ruhif was doing. He was predicting the angle that he'd just measured. And using the angle that he'd measured to predict the angle that he'd measured. I mean, 50, is that what we're going to do here? Are we going to get a measurement and then use that measurement to calculate how far the measurement should have been in the first place? I think.
Right. That's what they're doing. Exactly. That's exactly what they're doing. Oh my God. He's okay. We got the number, the measurement. Now let's calculate a number that isn't the measurement.
Yeah.
And then I don't know.
Yeah, we'll just do a calculation to make sure this measurement is on our globe, right? So, how far should we have travelled if we were to travel 1,200 miles on a globe? Wow, 1,200 miles? No way. We live on a globe. Brilliant. I think that's how this maths and geometry works. I'm getting the hang of it now. Is that
they
right?
swear they know math. That's what really is like, that's the insulting part. Is that they claim to have math on their side, but right off the bat, you're dealing with math is fundamentally almost rooted. Besides the circle, it's rooted in straight lines, and then there's just like that, and it becomes a problem.
You've got to stop using math, right? Because although math is, geometry is part of the maths, geometry is the foundations of the maths, right?
Geometry is defined, right? Geometry has a math doesn't. Math is just
there is axioms and all of that, but it's not necessarily built in the similar sort of logical framework that geometry is, right? It does have axioms and all of that, but they're not. It's not really the same as geometry. And they're right, it is some sort of a language, maths, but I mean, I think it's a language of wizardry, right? You can use it, but you can also deceive and put statistics and do all of that sort of shit with maths.
You can make, turn 1,000 into 10 million. Right? Like, if the sun is 1,000 miles, you can just say, 10 million, 10 trillion, right? Oh, it's so big. But it's huge, but it's further away.
Use the maths to make a formula that will fit anything you want, really. Because, that's what you're doing. You're formulating something to fit whatever you want. Like,
They think it's the other way around.
Yeah.
They think it's the formula... Oh, and the formula was right because reality fits to it. No, you saw reality and then made a formula fit it. That's no surprise. And then they're surprised that it fits. You made it fit. You took it from reality.
Yeah, it's F equals MA. It's like, well, what? A force? What's that? Well, it doesn't matter. MA, that's what it is. It's like, what? Force is mass times acceleration. That's what the M is, and that's what the A is. It's like, well, that's a force? Yep. MA. F equals MA. That's it. Done. Bam. Maths. It's like, no. That's just adding some letters there.
Hell of a discovery, isn't it?
What?
So, writing F equals ma.
That
Newton.
F equals MA.
Yeah.
My 3-year-old, if I had one, could do that.
So is that what force
Really?
is then? What's a force,
I
50?
think you're kidding yourself.
What is a force?
Force is anything that causes something to move.
MA.
Mass is something that takes up space and resists acceleration.
Yeah, well, no, but your formula says F equals MA.
Yes.
Right, so that's maths, right?
With physics and maths
Yeah, so the F,
coupled together
the force, is equal.
to mass times acceleration.
Right, so that's what a force is then, right? Surely that means that gravity cannot be that force, right?
Why? Why you say that?
Well, because it's mass times acceleration, right? And gravity
Well, it's
isn't equal to a mass times an acceleration, is it?
Well, it's not F equals A.
F equals ma.
Yeah, it's not F equals A. It's F equals MA.
Yeah,
So it's not saying that
m
force
times
is,
a. There's a function of a times in there as well, isn't it? Where you multiply a mass with an acceleration. I mean, like, come on, who can't do that?
Yeah,
Go
but
on, go and get your mass and times that mathematically by acceleration. Mathematically, of course, and then we'll call that force.
Yep.
Yep.
These are things constructed by man. They're discovered, and then we name them.
Discovered. They were out there, and we found them.
Yeah, I mean, you telling me that F equals MA didn't exist before somebody wrote it down?
So then it wasn't discovered; it was invented.
No, it's discovered.
So before Einstein or Newton or whoever, F equals ma was out in the wilderness like a wild, shiny Pokemon, waiting for somebody to grab it and discover it.
Yes, and write it down.
It was wrote down on a tablet that was searched for ages, and it was discovered.
Come on, man. Come on.
Like I said,
We invented that, bro. Humans invented that to describe.
Hold on. Are you telling me that before somebody wrote it down, it didn't exist?
Yes, that's exactly what I'm saying. F equals ma is first. Those are letters in the English language. So before the English language was invented, there was no F equals ma. So things still happened the same before anyone ever had the idea of F equals ma. So F equals ma is just mouth sounds.
Well, I'm talking about the meaning behind it, dude. I'm not talking about the specific language.
Language.
I'm talking about
It's
the principles behind it.
It's a way to describe.
Yeah, you have reality and you have the way to describe it. Those are the two constituents of our existence, okay? We exist and we experience reality, and then we use words, mouth sounds, symbols on paper to describe it. That's it. Now, you can't force reality to conform to your mouth sounds. It's the other way around.
All right, say that again. Say that one more time.
Okay, so reality consists of two parts. Us experiencing the empirical nature of the world. You walk outside, you touch a tree, right? Now, the other part is the words we use to describe what we do. Like when I just said you touch a tree, nobody actually touched a tree. I was just using the words to describe reality. So reality is broken down into words to describe and then the actual reality that those descriptions are describing. Now, in math, English, all of them fall into the latter, the describing of.
Yeah. Yeah, but like I said, even if nobody ever discovered or wrote down F equals ma, those principles would still hold true.
Because they're a description of reality.
Exactly.
But they're not, what they are is just words to describe reality. So when you say force,
Exactly.
yeah, so force is not a real thing, right? Like, and
It's
this is
not
the
a real thing.
no, force is a conceptual idea to describe reality. We just agreed on that.
Yeah, to describe reality, meaning
Yeah,
real.
so it's not real. No, the what is
Reality's not
being
real.
described, hold on, what is being described is real. The descriptor is not. Force is a descriptor. It is not the reality. So when you say F equals ma, if I was to translate that to reality, you would have to coincide it with the impact of one object to the impact of another, right? Or the moving of an object, like you throw a baseball. So the descriptor would be F equals ma. The what it's describing would be an object in reality moving.
I still don't get.
I mean, I
I
don't.
still don't get what distinction you're really trying to make here.
The distinction would be that what what we use to describe reality isn't real. So force, right? Force is not real. There is not a force out there that is pulling things down. There's not a force out there, right? That's Star Wars type stuff. That is describing the motion of a rock going down.
Dude,
So
you can measure force
you don't measure
in the
force.
real
Force
world.
is a descript. No, force is just a descriptor. You can't measure a descriptor. You measure reality and then describe it. So you measured the rock falling. The rock is what was measured. It fell down, right? Or it moved from point A to point B. You measured the distance between point A and point B. Like you took measurements. You're not quantifying a force. You're measuring how far an object moved.
I'm talking about like on a scale. Like if I stand on a scale, I exert a force. I can measure that
No,
force.
no, there's no force. Force describes you physically making contact physically with the scale. That's what force describes. So force is not real. Your body, and how it makes contact with the scale is. Force merely describes that event
I don't. I don't understand what would make you think it's not real.
because it's describing something that is real. So the descriptor
So,
is not
so let me
real.
say. So if I described my girlfriend, who's got double D's, blonde hair, big old booty, and is just smoking hot, I can describe her, but that's not real. She's not real.
All of those words you said are not real. They are describing the piece of ass in your living room that's not there. Do you get what I'm
She is there
saying?
though.
Okay, whatever. What I'm saying. So, okay, I'll give you the benefit of the doubt that you have an actual another physical human in your living quarters. We use
I'm gonna
words.
call you a liar.
Well,
No.
if he's got a child, then we can at least assume that he's. But anyway, so the idea that the physical
He's
object,
quite vivid.
we'll give it to him. I'll give it to him. So the physical object of the girl, her skin, her bones, her blood, real. the words you use to describe are not real, right? Because double D's, you don't. That's just words. The actual physical breasts are real. The physical girlfriend is real. The descriptors are not. So when you take that whole nother descriptor to F equals ma, the descriptors force is not real. The thing in reality that's it's describing is.
Okay. Still doesn't change anything for me though. I don't understand that.
Because so then force is not the thing.
It's kind of a meaningless distinction to me. If I think I'm
Well,
understanding you correctly.
well, if there's no force, there is no force, right? There's no force that is doing anything. And this is the foundation of the ball model, is that it's built on the idea of there's this force, right? Then
well,
this force.
I don't think it's more of a fact that the whole thing is based upon somebody else has took this, like he said, it describes shit better. Well, does it? Like, I don't actually think it does. I think it just gives you a way to hide these little wizard magic tricks within shit that even they don't understand. But they can just go, oh, well, it's scientific. F equals ma. It doesn't actually mean anything, does it?
Look around you. Everything you can see right now is given to you through the application.
Is that the best you can do at describing it, though, 50? I mean, like, if the best you can do in order to describe things moving around is by saying F equals ma, that's not really a very good description of what is actually going on. I mean, I'd more listen to Right the Hand try and explain what his interpretation of it is, because it's more of an explanation of what's going on. F equals ma means fuck all unless you can use your words to describe it better. I'd much rather listen to Right the Hand explain it than you saying F equals ma. You know, it doesn't explain anything. And saying some mathematical equation doesn't mean fuck all.
I mean, you kind of have to understand what the things mean, but to say it doesn't mean anything is just patently absurd. It's built the modern world around you. Literally
It's your
everything you
chance,
see.
though, to explain to us how much you understand it and how easily you can describe what exactly is going on behind the function of F equals ma. But I'd say you can't, because you don't understand it. You don't even know what it means.
Oh, fuck. I'm an engineer. I don't know what F equals ma means.
Well, please explain it.
F is so these are constructs that humans discovered. And then we had to develop these ideas around the principles that we discovered, give them names, give them units, give them a little bit more meaning and context. Force is something that we gave a name to. The definition is force is anything that causes an object to move. Anything that causes an object to move is a force. As simple as that. Then you have mass. Mass is anything that's an object that takes up space and resists acceleration. Acceleration is something that causes something to have increased velocity.
Resist acceleration.
What?
Resist acceleration.
Complicated, bro. How about this? We have objects and we move them.
Yes.
What do you
So
think
you have
about
to-
that? That seems
you
a
have to
little
apply-
simple.
You have to apply a force to the mass.
No, you just
and
move
it
it.
causes it to accelerate. So
What do you mean by apply a force? What would that entail? Applying a force.
that would entail you pushing on something or
So I gotta
blowing on
touch it.
something.
Or blowing.
So
You
physical
use a
contact.
magnet. Like for instance, with that equation, right? I could tell you if you have a truck outside that's got a load, it's got 2,000 pound load. I could use F equals ma to calculate how much horsepower you're going to need to pull that, and tell you how much power is required
Horse
to move that a certain
power.
distance. Also, I could tell you how much energy is
You're
required to
using
lift it
horses.
in an elevator. Yeah,
The power of a horse you're going to bring into
yeah. I mean,
your force equation.
that's what we used to get around. I'm pretty sure a newton is the force
Descriptor.
required to move a kilogram 1 meter.
Descriptors, bro. You're
Yes, exactly.
describing.
They're
This is
descriptors.
all you're doing. All you're doing is describing. Okay, these are descriptors
Yeah.
of reality. Okay, so
What's the
the
problem?
the problem is that you think force is real.
What makes you? What makes you think it's not real?
Okay,
I can measure it. I can design.
you've measured. Okay, you've measured a force by itself.
Yeah.
Okay, Nate, show me a time when you didn't measure a physical object, you instead measured a force.
Well, I have a scale here, and
That's a physical
I
object.
have a magnet on top of it.
That's a physical object.
Yeah, that's the mass
So
bit.
so we live in a physical world, and you want
Yeah.
me to, and you want me
Not.
to. You
You're
want to
the
go to
one
virtual
that.
space? You want to go into
No,
the Matrix,
no.
and I'll show it to you there?
You said you could do it. You said I was wrong. You said
Yeah.
no, everything I'm saying is crazy. I could do it. Watch, and then all you could do was default to my definitions, right?
Well, I
That
don't
you
know
need the
I mean,
physical
I
object.
don't know if you're moving the goalposts on
I
me here. I
said
think.
I said measure a force without a physical. I said, could you measure a force without physical objects? You said yes. Then I said, okay, how would you do that? Then you named two physical
I thought
objects.
you meant without like something touching. The two
But
objects that are transmitting forces touching.
I'm
I
trying,
thought
bro.
that's
I'm
what you
trying to
meant.
get you to see that you don't transmit a force. If I take a
Dude,
water
we
gun,
live in a physical world.
yes, and force is not a physical thing, so it's not in our world. It is.
You tell me this. How can I build a machine designed around those principles that works if they're fake?
No, what I'm saying is force. Force does not exist in our world because it's a conceptual descriptor. When I use my hand to squeeze an orange, I'm not using force. I'm using my hand.
You're applying a force with your hand.
No, I'm applying my fingers.
He's
You're doing
flexing
this,
his
No,
you're
muscles.
force
doing
is
this
not
weird
real.
thing.
Can
You're
I
doing this
jump
weird
in?
thing
Let
where
Gio first.
I,
you're
I
doing this.
wanna take his side for a second.
Go on.
Can I do that?
Yeah.
Okay. Magnetism. Just
Love it.
magnetism. I think magnetism is a force.
It is
Okay.
electromagnetic force.
No,
Okay,
not electromagnetic. Just magnetic force, because I can feel the repulsion in the magnets when I try and put North Pole and North Pole together. I can't. There's
You feel the
something
magnets.
stopping. There is something stopping me from putting the North Pole to the North Pole.
And that
Of a-
thing
Correct.
and that thing that is
Yeah.
stopping the magnets is real. Now you can call that thing. You can call that thing an elephant. You can call that thing unicorn farts. You can call it force.
Well,
You can call it energy. You can call it whatever you want. The words that you call it are not real. The
Right,
thing
I
that
get
you are calling it is real.
Yeah, I wanted to agree that I would call that a force. And I,
Yeah, you can go. I have no problems with that. Call it whatever you want, but what you are
we're on the same page then.
describing is real,
Look,
not the
Yes,
check it.
we're on the same page
Check it
then.
out. Check it out.
Never mind. 50's still drunk.
Can I say something real quick? They're quantifiably, empirically real. I can show. If I push on it, it'll read 50 pounds of force. We can calibrate it, and I can also take that same scale and I can push it against a car. Let's say I place it against like the back of a car. I can push it against the car, and I can show you that it takes so many pounds of force to move the car. And I can, put it on
No,
my
no, no,
girlfriend's
no,
my girlfriend's
no.
ass,
Hon,
and I can
I
kick
gotta.
it in the ass.
You're not
No, I
showing.
got lost in the sauce.
You're not showing me 50 pounds of force. You're
What am I showing you?
you're describing the event that you witnessed.
It's quantified.
No, you
It's
didn't quantify
quantifiable.
anything. You didn't quantify. Look. You didn't quantify a force. Okay. The scale is programmed. It displays an output that is programmed to display. You are not establishing a force as being real. The
What
scale
about
is
just like
real.
a teeter scale, a teeter-totter
Okay, but
scale?
okay, yeah, it doesn't matter. It doesn't matter what it is. The scale. There's when you say real, you have to understand.
Wait, can you just call it a teeter-totter scale?
Yeah, like you know what I'm talking about.
Yeah, oh yeah, I know what you're talking about.
Like a balance scale, like a balance scale. Yeah. The idea though is that real is talking about the things you are describing, not the describers. And this is the biggest, when you start turning what you are talking to the reality, that's you make this ball. This is how the ball is made through these things, right? The rock falls, which is a force and acceleration and then gravity, right? But rock falls. Then they made a force to have acceleration to have gravity.
Yeah, but you can then quantify it, and then you can extrapolate it and build real-world objects with that information, proving that it just like electricity, just like I can prove that electricity is a real concept. I can shock you, bro.
Yeah,
That's electricity. You gonna
okay,
call
but
that fake?
but the thing is, when you say electricity, are you talking about like electrons, or you would describing me getting shocked?
Well, I mean, I'm talking about electrons, right? You can see
Okay.
them.
Oh,
You can see
you
them arc.
see, you see electrons.
Yeah, you can see them arc.
Oh,
When you see the light
so
that they emit,
we can see with our naked eye electrons in a taser.
you can see the light that they emit.
What? No, again, you're describing. You're making the take. You click a taser and you see that blue thing. Okay, that blue thing is not an electron. That blue thing is that blue thing. You can describe it.
Uh,
See, you
but
created. You've
couldn't
made
that
the
blue thing
electron real by
millions of
describing
electrons?
something.
No.
What'd you say?
I was just saying, couldn't that blue arc be billions of electrons?
Yeah, that's basically what I'm saying. It's a conglomeration of
That's
electrons
what I thought.
Well, how do you know it's not one line of electrical rope?
because of lots and lots of science that came before it.
Well, but again, this is where it just
Can you
you don't.
bring up any of
You,
that science that came before it?
we would have to do a deep dive to get into that. But here's the quantifiable definition of a force, a newton. Okay, the SI unit of force is equal to the force that would give a mass of 1 kilogram and acceleration of 1 meter per second per second. Right?
You're okay. You're just okay. First, so you define force with force. The SI unit of force, it is equal to the force. You're just using a word that you don't really understand
If
because you're
force
trying to
force
describe
is
something that is look, you're trying to describe something that is indescribable. Like,
I described it to you earlier. It's something.
you're not though. Like, if I kick a ball, right? You can't describe it went far. You can say how far it went, but you can't give me a quantifiable how hard I kicked it
Yeah,
because
I can.
hold on, how hard I kicked that ball is all just relative. You can't say you kicked it 5 or you kicked it 10, and that's what
Yeah,
you're
I
trying
can.
to do when you no, you can't.
I absolutely can.
No, because that is not that
Absolutely.
no, because it's non empirical. Like if I kick a ball and it goes 10 inches, now we can all measure 10 inches, 10, 10, 10. Now, when you try to apply how hard I kick that ball, you can't because there's nothing to measure except the distance that the ball went.
We know the mass of the
No,
ball.
okay, but all you know, the only thing you can measure is how far the ball went. So you can't measure a force.
I can measure that. Why can't I measure the
No,
mass?
no, you can calculate a number and then say that number is a force. That's all you can do.
Yes, and
Well,
I can
that's not
also have you kick a scale.
okay, but it's the same thing. I kick a ball, right? The ball weighs 10 pounds, it went 10 feet. Now you do some math and come up with a number and call that number a force, but you never measured that force.
No,
The only thing you measured empirically was the weight of the ball and how far it went. You calculated the force or you invented it in your head.
correct. And we know
Yes, correct. So
from
it's not real. If you invent it in your head, it's not real.
it's a discovery. You can prove it in your living room that F equals ma.
No, and you're
This
just
is listen to me. This is the foundation of the entire modern world. F equals ma is the
you just said
beginning
it was
of
invented
the
in your
modern
head.
world as we know it.
You just said if you weren't listening when you just said it was invented in your head.
It's a discovery. It's a calculation, and
That's
it's
in
all.
your
It's,
head.
you can calculate it or you can measure it.
But no, you don't measure it. You never measure it. The only thing
You
you
can
do
measure it.
is in your
I'm
head. The thing you
I'm
measure.
stepping on a scale right now, dude.
No, okay, on. This we'll go to the ball.
Stepping on a scale
You,
right now.
yeah, I'll show you. You kick the ball. 10-pound ball, it goes 10 feet. Those are your measurements. The force is a calculation in your head. So now the scale is programmed. The scale is just like you stepping on a ball and then the ball rolling 10 feet, right? You 10 pounds, ball 10 feet. Those are your empirical measurements. You never measured a force.
I could have you. What about a balance? What about scale balance?
That's you're measuring, okay, the weight, not force.
That is force. That's the definition of force. F equals mg.
I'm not telling, bro. I don't care about your definition. I'm telling you what you measured, right? What is real is the object on the scale. Now
Yeah, you
the
measure.
calculatory equations in your head are not, and force falls into the calculatory equations in your head.
Their discoveries. We discovered.
What is a discovery?
Man discovered that F equals ma is a law that the universe operates by.
What?
It's used to build your
No.
car.
50.
It's used to build your
50. Can I
home. It's
just
used to build
come in
all
with
kinds
the.
of different devices.
Because it's maths, F equals MA, right? You realise you can flip it around and do all sorts of weird shit, right? So the mass, right? You can work that equation out for mass, can't you? Do you realise what mass equals? What force
Over
divided
acceleration.
by acceleration?
Yeah.
Right. So you think you can work out the mass of something by working out the force divided by the acceleration.
Yeah.
Yeah, if I know the force and I know
Go
the
on then.
acceleration.
Right?
Go on then. Yeah, yeah. So you find the force of something, and you divide that by the acceleration, right?
Yes.
And then that will give you mass. Is that like a weight?
Well, no. Weight would be relative to
So
Earth's
what's the
gravitational
mass
field.
then?
But yeah, kind of.
What the mass would come in at a weight.
Mass is anything that takes up space and resists
Yeah,
acceleration.
does that?
Weight is
I
something
know.
specific to
I know.
Earth's
It's
gravitational
mathematics.
field.
It's mathematics, right? So you could
Physics.
you could find a force and divide that by an acceleration, and
Yeah.
the outcome of doing that would be a weight. Does that
No, it'd be the
actually make
mass.
sense?
No, it would be the weight equals mg. So F equals ma, weight equals mg. So it's kind of the same thing, except F
No,
is
we're
replaced by
talking about
W,
the mass. You'd
and
be
G is
able to
replaced by
work out
G.
a mass by
Yeah,
finding a force and dividing that by an acceleration.
correct, correct, correct.
Okay, so
These are the
can
same
you
principles
can
that
you
the
just I know, but can you just envision that in your head, right? You're doing a mathematical sum, right, for something in reality, right? Now, first off, you have to get a
yeah,
force, right, and then divide that by an acceleration, like you would
yes,
do. Imagine one of them's 8 and the other one's 2, like numbers, right? Maths, right? 8 divided by 2,
yes,
bam, 4,
yes.
right? Force divided by acceleration. Go quickly, come on.
4 if your units are proper.
4.
What?
No. Just the force and the acceleration. I was giving you 8 and 2 as an example, but you've got to put your force and your acceleration in the place of that for the maths to give us
Yes,
the m.
mass equals force divided by acceleration. You said 8 divided by 2.
No, that was that was like to help you understand how that one divided by the other works, right? It was up to you to put a force in the place of the 8 and an acceleration in the place of the 2, and
Why?
give us the m in place of the 4. Because it's maths, right? It's dead easy to describe things with. It's much easier to describe things with that sort of maths for you, obviously. So off you
Why?
go.
I, so what? You're not. It's not really making much sense to me, dude. Okay, so we got F equals ma. You're giving me what? You're giving me what?
We're working out that formula out for m, for
Okay,
the
so
m
you want me
derivative
to
of that
solve for
formula.
m? Okay, so m equals F divided by a. I'm
Yep.
assuming we're working in British units, imperial units. Okay, what do you want me to do?
Just realise that the fact that the F equals ma, the only real thing within that is the m, right? The force
Yeah.
and the acceleration. What are they?
You don't know what acceleration is? I mean, come on, man.
Go on then, explain it. Go on. Can you show us it physically?
Acceleration?
Yeah.
Yeah, I can show it to you physically. You'd have to be over here. Just drop something, you'll see it accelerate.
That's moving.
And I would see an object.
That's
You would see an object accelerating. If it's something still,
I wouldn't see the
or if something's
acceleration though,
still,
would I?
you would see the acceleration.
No, I would
If
see the
something's-
object.
You would see the object accelerating. You could film it. You could then calculate the exact acceleration, and you could see that's 9.8 meters per second per second.
Yeah, okay. Yeah, and you would
And
use that force to divide it by that, wouldn't you?
Yeah. I just don't get. Kind of get what dude's trying to say, but I don't. It just doesn't get us anywhere.
No, I
Like
know.
these are. I don't.
You-
It just doesn't make any sense. Like the
you
entire
turn-
world is built on these principles. Is built on the principles
Look,
that these things are real. You can prove them in your living room that F equals ma. It's provable
you turn
over and over
you
and over
turn
and over again.
You turn one thing into three. You turn the mass into three separate things. It's like the Holy Trinity. You drop a rock,
No,
rock.
turn one. They're three separate entities.
This is how I'll show you. The rock, the mass. The mass goes down, hits the floor. The mass becomes the A and the F and the M. You created the Trinity from just the M. Hell.
If you have a rock and you're holding it, at that point, at that moment, it has potential energy, gravitational potential energy. Once you release it, it changes from potential energy to kinetic energy as it accelerates downwards. Once it hits the ground, it hits it with a certain amount of force, and the energy is dissipated, and then you're left with the mass at the end.
That's all there
Nothing
was,
else.
though, isn't it? The mass didn't change.
No, the mass never changed, right? But it's just, I don't get it. I don't understand why you would say that that's not real, or I don't know. It's weird to me
They're
why
just
you would say that's not
descriptors,
real.
dude. They're just the F and the
They
A
are.
are just descriptors, right? And it's
Yeah,
up
they're
to
descriptors
you,
of real things.
yeah, to try and explain them, right? It's just somebody else at one point decided that that was a good descriptor for what was happening, right? Now, he's just put it into F equals MA. Well, that to me, it isn't really a descriptor of anything. It
What is
doesn't.
it?
It doesn't actually describe anything, does it?
It describes how it describes fuck. It describes how that system works.
It's just some letters. Like until you or
That
somebody
have
else,
meaning.
like somebody who can obviously describe these things very well. And actually, the simpler that people can describe them, that would be better, right? That'd be great if we could do that. If we could find somebody who could explain all of these, what seem to be, indescribable, because you're really struggling.
I'm not really struggling. Describe it in one sentence. Force is anything that causes something to move. It's as simple as that. One sentence. Like how many words? Like 5 words?
Okay, so I dropped the rock. It falls to the ground. What caused it to move?
Gravity.
So what is that?
Excuse me?
What is that? You're just saying words. What the
An acceleration field.
a force?
No, not a force, an acceleration field.
So it wasn't a force that moved that rock. But
It's a
hold on. So it wasn't a force that moved the rock, but the rock moving is ma. Isn't ma equal to F, which is force?
they're coupled together.
Oh,
It's a proportionality. M is a proportionality.
Discoveries. 23. He's down to 23.
between F and A. Okay, there's two things
Okay,
in
wait,
between
hold. Bro, you don't. Okay, we'll do this.
There's an acceleration field.
So it's an
There's an
acceleration
acceleration field, and if you place
A
a mass
field.
in the acceleration field, that will cause a force that will move it to go towards whatever direction the
Where's
acceleration
the
Field.
acceleration field?
is going.
Where's the acceleration field in F equals ma?
Do what?
Where's the acceleration field in F equals ma?
A.
Oh, so A is an acceleration field. It's not the acceleration of a particular individual object.
Well, it's just acceleration. It can be any type
Entire
of
field
acceleration.
of acceleration. Yeah, I'm growing acceleration in a field next year.
Yeah,
So
I like
Well,
that.
it's
Farming
it's a vector field,
accelerations.
just like a magnetic field, right?
I'm an
Every point in
Oh,
space
a
has
magnetic
a
farmer.
quantity associated with an acceleration. This is like every day on Earth, you witness things accelerating towards the Earth every day. Like your entire life's journey has been you witnessing everything fall towards the mass of the Earth.
I've seen a few balloons go upwards. In fact, I've been in one of them.
Yeah, that would be an
That
engineered
wasn't. We weren't
object, right?
falling.
Well, that's an engineered object, right? We know the reason why that went up because it was engineered to go up, right?
Well, yeah, but it didn't go down. It went up.
Yeah, because it was engineered to do so.
It's engineered.
Yep.
The hot air. We engineered the hot air.
Yeah. Well, I thought you just said helium.
Now, that's natural, isn't it? No, it's not. It was a hot air balloon, right? Not helium. It was a hot air
Okay.
balloon.
Are you telling me that the hot air balloons aren't engineered?
I would say that the hot air
nature
isn't
pops them out?
engineered to go up. No.
What? Hot air isn't engineered to go up. Hot air itself isn't engineered to go up, but hot air is lighter than cold air. And if you have a large container with hot air, there's something called the buoyant, which engineers know causes things to rise. So you're using
Sorry,
the
what?
scientific principles to engineer a hot air balloon using the buoyant force and the knowledge that hot air is thinner, less dense than cold air.
Ah, density. There you go. Yeah, we got there. We got there in the end. It's the density difference, right?
Yeah.
Yeah.
I could debunk. I could
So that's that.
debunk the
Is that
density.
engineered to be the upward thing, the density difference?
The buoyant force?
No, just the density difference, right? Because that's all it is, right? Are you calling that density difference a buoyant force? Like it's a force.
No.
It's like weird, isn't it? Like you're actually F equals ma, and you're saying the density difference would be the ma, would it?
The buoyant force is F equals rho GV.
Okay.
Density times volume times gravity.
So F. That was an F, was that?
Yeah, force.
That was another force. So is that a different force than the F equals ma? Then
It is. It is.
with a new thing.
Yeah, rho VG.
Okay. So what's that then?
Rho is density, V is volume, G is gravity. And what's happening is
So that's
air is
wait a minute. That's a
squeezing the
force. Wait a minute. That's a force. So what's gravity then?
balloon. Well,
Because that's not a force, isn't it? So you've enveloped something that isn't a force, and you've put a F in front of it, so that something that isn't a force has suddenly turned into a force. That is it. That force that orders the density then?
Well, gravity generates a force. It's not a force
What, the
itself,
density?
but it generates a force.
That orders what layers the density gradient goes in.
Yes. So, like for instance, if the gravity was stronger, the buoyant force would be higher. You could do this.
What do you mean it would be higher?
in,
You mean
huh?
that the stuff that would be at the top of the density layer would be at a different place in the density. No, it would still be at the top, wouldn't it? So how does the gravity affect at what point the density layer goes in? I mean, like how does that affect?
It's squeezing it. Just like Archimedes' principle.
Squeezing it.
If you think about water, if you think about water,
right?
How
does it squeeze? Does it have a
I'm
vector?
trying to tell you.
Okay.
If you have, I'm sure you know about Archimedes' principle. If you submerge let's just say a ball, a sphere, the reason that sphere is being pushed up is because the ball is being squeezed by the water, being squeezed upward, because there's higher pressure at the very bottom of the sphere, and there's lower pressure towards the middle of the sphere, the top of the sphere, however far you submerge it. So there's a squeezing action going on. It's squeezing it upward, and that squeezing force is
It's
equal to
another
the weight
force.
that it displaces.
Getting these forces are everywhere.
It's the same thing. It's the buoyant force. The buoyant
squeezing
force.
Squeezing force
Yeah.
of the water is
Yeah,
what the buoyant force. I'm loving your descriptions.
Yeah, the buoyant that's the way it works. The buoyant force is a squeezing force, and it works the same in liquid as it does in gas. They're both
I'm
fluids.
liking your ones better. That like Newton's with his F and rho and all of that bullshit. I'm liking yours. The buoyant force is the squeezing force. I like that. It's a good descriptor. It doesn't really make any sense, to be truly honest with you.
Well, hold on. I'll post you a picture.
Picture. And this is that. It's that orders the density layers.
What's that? No.
Well,
what do you mean that orders the density layers?
Because that's what you said. Like, initially we said that the warm air goes up. Now, you said that is because of the difference in density, right? And the volume, obviously. Yeah?
Yeah.
And that caused that to go up. And then you said that up was a result of a buoyant force. Right? Now, that buoyant force contains gravity, which is a downwards, right? So, how does that vertical direction, right, in the downward direction, because that's how gravity acts, isn't it? How does that equal an upward force? How does that downward G that you've added into this buoyant force cause warmer air to go in the opposite direction?
You'd have to look at the picture I posted in debate discussion. So this shows you what's going on, right? So we all know as you move up that the pressure decreases, right? So there's less pressure at the top of my head, and there's more pressure at the bottom of my feet, right?
Right. So you're talking as a fluid there, right? Are you talking water?
It works the same in fluid. It works the same in gas.
In air.
Yeah, it works the same in air.
Because that's what we're talking about here, right? Because it's a hot air balloon.
Yes.
Okay.
Yes, it works the same in air. So at the bottom of the balloon, there's more pressure, there's higher pressure, and it's squeezing the balloon up. And at the top of the balloon, there's less air pressure. So there's the sum of the forces acts upward. And you can do this There's actually like some really high-end scales you can do that are vacuum scales where they pump all the air out so that you don't have this buoyant force, so you can get really accurate, precise measurements.
Sorry,
And
sorry. Say that again. I've never heard of them before. What was that? It's
there's
scales.
there's special scales that you can buy that pump out all the air and create a vacuum, and then you can weigh an object, and the buoyant force won't be present, and you'll get a perfectly accurate reading.
You can weigh something in a vacuum.
You can. That's how you get rid of the buoyant force.
Right? Is that not just called a vacuum?
What do you mean? Is that not just called a vacuum? Yeah, I mean,
Well, you said there's a scales where they pump it out. Is that not just like a set of scales in a vacuum?
yeah.
Yeah. So it's not really a device. It's a vacuum.
Well, whatever.
And
I mean,
so
there's more than one
in
way
a
to describe
vacuum,
things.
does stuff not weigh anything? Does stuff float in vacuums?
No, stuff
Oh.
doesn't float in vacuums. It just takes away the buoyant force, so you get a perfectly accurate representation of how much it weighs. You don't have the buoyant force that's present, so you get a more accurate reading. Like there's like if you look into the science of how they weigh things precisely,
Right. So
there's a building in the U.S.
you get
Huh?
rid of the density gradient by getting rid of the density gradient. Right. There's nothing there.
Yeah, I mean, or you could calculate for it.
Or you
There's a
can
building.
calculate it for it. No, but I mean, the whole idea was for you to explain the density gradient and the ordering of the density gradient. So what you've just explained is that you get rid of it.
Yeah, well, you can make it more precise.
But you, in
I
order
mean,
to
my
measure
original,
the thing that causes the density gradient, what you do is completely get rid of the density gradient.
if you want to be completely accurate with your measurement, yes, or you could calculate for it. But regardless, gravity orders things, right, in such a way that air is denser towards the ground and it's less dense as you go up.
Yeah, that's the
So
density
that
gradient.
ordering,
But you
yes,
just claiming gravity does that. I mean,
yes, I
what
am.
sort of evidence have you got that says that gravity does that?
Well, my entire life's experience.
Right. Well, you know, like you know where the biggest density gradient changes that you can normally see. Do you know where that is?
Say that again.
Like where the most obvious density gradient changes.
Where the most obvious density gradient changes.
Yeah.
Air?
Yeah, that's one of them. Where do you
Is that
think
what
the
you're
other?
talking about?
Yeah, where do you think the other one would be? Density gradient, right? One density meets another
where-
density. Go on, have a guess.
Hold on, I can't hear you. Hold up.
Oh, he's struggling for.
Do you know where your density gradient, the most obvious density gradient would be? You've got the air part. You know where the other one would be?
Liquid?
Way, there you go. Now, you know that surface, because you're talking about G, aren't you? Has a axe in a certain vector.
What? Say that again?
Your G, gravity, right, that
Gravity.
orders these density gradient layers.
Yeah.
Can we call them layers?
Sure.
And we have air as one layer, and then some liquid. Call it water, right? Just a random liquid of water meeting the air, right? There would be a meeting of two density gradients. Yeah. Now,
Okay.
you have a force that you say that helps us order these density gradients, and it has a vector,
Yeah.
doesn't it?
It does.
What would you call that vector?
Toward the center of the Earth.
Yeah.
Toward the center of the Earth.
Is that the best you could do?
Down. Down towards the ground.
Yeah. Like, is there any tools that we could do to get that, use that, to find that particular vector?
Yeah, you could use your phone. You an accelerometer in it.
No. That's like the vector, not the acceleration or anything. Just the vector is all we're after.
Well, it's the vector of the acceleration field. So.
Yeah. Is there a tool that we could use? A very simple one, I reckon there is.
Accelerometer.
Yeah, I'm thinking a bit more basic than that.
What, a
plumb bob?
Plumb bob?
Yeah.
Yeah.
Yeah. Right. So that is a device that establishes a vertical, right?
It does. It does.
Fantastic. So that vertical is the thing that's helping us order our density gradient layers. Now, let's suppose we get some of this liquid and put it in a tube and make a big massive body of it, right? And we use this vertical thing in order to order our... Now, is there any way that this gravity works? Is there any other geometrical terms that they say it works in order to layer these gradients?
I'm not sure what you're getting at.
I think I'll give you a hand because this is a bit technical. It's perpendicular, isn't it? It's like...
Yeah, the layers would be perpendicular, sure.
Yeah, to that vertical.
Yes.
Yeah. So that would make the density gradient layers horizontal.
Yes, that's what makes the squeezing force.
And those horizontal density layers, would they be parallel?
No.
No.
They're spherical.
How? How do you do that with perpendicular and vertical? Where did you just inject a sphericity to that? I mean, how do you get density layers that are horizontal, right? They're vertical and it acts perpendicularly, which makes them obviously horizontal layers.
Yeah, well,
they surely must be perpendicular, because you can't have horizontals intersecting with another horizontal, can you? I mean, that sounds fucking ridiculous. Does to me anyway. Does it not to you?
No, not ridiculous. I mean, there's always a margin of error.
Yeah.
So
like you can imagine that density layer being a spherical.
Yeah.
Ah, see, I can't. They just look like horizontal layers to me. I mean,
that's how right now we're working at my engineering firm. We're working.
Oh, you've got an engineering firm, or the one that you work for?
Firm. It's not my firm. It's who I work for.
Okay.
We're reworking the plumbing in the city, and we use the WGS model to determine the height difference from point to point, so we can determine the head pressure of our pumps.
Is that not just a straight plane though? Are you not on a state plane
No.
coordinate system. Yeah, I think you would be. Like,
Well, we're not. We're not.
yeah, you won't be. You certainly won't be using sort of spherical grid positions or anything like that, will you? I mean, especially if you're dealing with the head pressure. I mean, the head pressure obviously has to be a horizontal, doesn't it? I mean, that's where the head of the pressure comes from.
It comes from the altitude difference, and we get the altitude difference from the WGS map.
No. Altitude is just above that 1 point. I mean, it's the vertical distance above the bottom of your water pressure, right? Because that's where your water pressure comes from. It's from the vertical distance from the head. Right? I mean,
Yes,
Yeah.
but you have to. You have to take into account altitude. It's not.
no, it's just
the
the,
WGS.
no, dude, just the vertical distance. Doesn't matter how far horizontally you are away from it. But the only thing that matters, I mean, you should know this if you're doing plumbing, and you're after thing, is just the head of pressure, the vertical height, the difference between the top and the bottom of the body of water, right?
Yeah, but we're talking over miles here.
Yeah, it
So it's
doesn't,
not-
like I say, the distance, the horizontal distance, doesn't matter. The only thing that matters is the vertical distance.
Correct. The altitude,
It's,
the height above the surface of the Earth, or the
No,
height.
just the difference between the top of the water and the bottom of the water as a vertical distance. That's the only thing that matters when you're talking about your head of pressure. There's no curve involved at all. Just vertical.
There is. We use the equipotential surface map.
But elevation definitely isn't curve, is it? I mean, you know that elevation, right? A change in elevation is a change in vertical, right?
Say that again?
A change in elevation is a change in the vertical distance. Works with altitude as well, but
Yeah, but all verticals aren't the same. You think all verticals are the same? I think vertical A and vertical B are two different verticals.
well, they are two different verticals, aren't they? Because they're in different positions. They're still both vertical, and they are still both perpendicular to horizontal. Now, when you establish your water head pressure, you are taking a measurement at the top of the head and a measurement at the bottom of the lowest part of the thing, and you are having a vertical difference between those two.
Yeah, but we also have to reference the WGS equipotential surface map.
Do you?
Oh, fuck me. Yes.
So
Yes, we do.
it isn't just that vertical difference then?
No, we have to reference the equipotential surface.
Just explain the equipotential surface for us.
The equipotential surface is a well, I mean, it's basically just what's defined. That's basically what it is. It's a equipotential surface where basically defines. Damn, this is kind of hard to explain. So at one point, it's kind of like a what's the word I'm looking for here? Like an elevation map. You ever seen an elevation map where it's got like the rings?
Yeah, I've seen an elevation map. It's like a side view, isn't it? I mean, I did it when I was doing my building. We had to draw them. It was before CAD and all of that, so we actually had to draw them. Actually, I've got a drawing board because I'm going to do it myself. I'm going to do an elevation map of the Leeds to Liverpool Canal. So yeah, I'm quite familiar with elevation maps. Yeah,
So it's basically what it is. It's a elevation map of the equipotential surface of the
equipotential surface. Go on, explain that. That's
well
what you were doing.
each it's a sphere. It's basically essentially a sphere, and the equipotential surface is at that defined elevation. That equipotential surface has a defined gravitational acceleration to like
A what?
so many significant figures.
A gravitational acceleration.
Yes. So like it would be akin, like I said, to an elevation map, and it
Do you want me?
would show you the
I've
differences.
got an elevation map. Do you want me to get you to show you one? This is one that Slice Bar Kane found for me. It is very nice. It's very generous. Of is it the Leeds to Liverpool Canal? I think he was very, very generous. I've been looking for it for ages, and I'm gonna replicate it, but I'm gonna have to call the places to find out the exact measurements and all of that. But I mean, what do you reckon to that? Is that the sort of thing you're talking about?
No,
Do you like that?
no, it doesn't look.
That's an elevate. That's the one that Slice Bar Kane gave us
Yeah,
for the
that's not.
canal system for the Leeds to Liverpool Canal. 127 miles that is from one end to the other. See that bit? See that bit on the left hand side where it goes straight for like 20 odd miles
Yeah,
without changing. Like, well,
yeah.
that's the bit of the canal where I live round right. That's where, when I decided to have a look into this, that bit of water there, because that's 27 miles in between locks. There's one lock at one end. Well, there's like 4 from the Mersey. It shows you there on that little step up. There's 3 or 4 locks there. And then you go up to that, and it's about 51 feet all the way across, all the way, same elevation for 20 odd miles. Is that what you mean? When there was, when with your, what was it, equipotential?
No, I don't think so.
Oh.
Hold on. Let me pull one up. I'll show you.
But so that isn't the sort of elevation map that you were thinking of then, no?
No.
Oh.
Not that we're looking at.
Is it because that bottom bit's a bit too straight for you?
That could be used. I don't see any problem with maybe that being used, but that's not.
Because that is a canal system, right? The locks of the canal, like every bit of the water in between is like a one body of water, right, in between the locks. And then they use the locks because you want to either go up or down in elevation, right? So you'd move up and down in that vertical direction, perpendicular to the surface of the water, which is horizontal, and your elevation changes would be in the vertical direction, perpendicular to that surface. Right? Makes sense to me, anyway. Wow.
Sure.
Yours looks like a wheel. Why do your drawings always look like that? Circles stuff. What's that about?
Well, that's what it would be. So it's not perfectly circular, but each line on there details is an equipotential surface, meaning that each sphere or each circle is a circle that has the same gravitational potential energy from a specified datum.
Right. Who do you think you're impressing with that? Go on, say it again.
So each each line or each circle on that drawing is basically is the height difference from it's an equipotential circle, and it's the gravitational potential energy from a specified datum. So it's a little complicated, but it's just basically the gravitational potential energy from a specified datum, essentially.
Okay, that's a new one. Can you explain potential energy for us, please?
Potential energy is the amount of energy that you can extract from a system. Do basically the amount of energy you can extract from a system from some datum level, right? So
Right. So
if I
there's
have
there's something to be extracted from these circles.
yeah, so let's just say the datum is the second one from the very outside one. So that would be the datum. And then if you move to the second one, the most outside one, the very outside edge,
Sorry,
and
are
we
you using this as your map to explain how you are getting the head of water pressure within the plumbing for the city? This
yeah,
is
but we have
this is
we have
the sort of
no,
map
well
that
this
you're
is
using to
well the kind of
work
maps we're
out.
using the kind of maps we're using aren't really available online, and you would have to. It's just not something that's available to the public. I don't think it's something that's in the engineering sector, and it's basically a slice of the city in 3D that and it shows these equipotential
A slice, like a
levels.
horizontal slice.
No, no, not like a no, not like a horizontal slice. There's arcs. It depends on how far
It's
it
like
is,
a
and
horizontal arc then. Can you think of it
no,
as an
no.
arc? It looks horizontal on the map at
Well,
least.
it almost looks horizontal.
Because the maps are 2D, right?
No, these are 3D.
They're 3D maps.
Yeah, I mean, I said it's a CAD model, kind of.
Wow. So you've got a 3D CAD model in order for you to work out the head of pressure.
Yeah.
Wow. How? So you actually work that out as a distance, right? Not as a pressure. Or do you work it out
What?
as a pressure?
What?
Do you know by the
Head
amount
is
of pressure you have how much of a head of water you have because of the pressure?
well, head is pressure. Head's another term for pressure. It's basically a term that's used in the industry that defines how far a pump can pump water up. Like if I had a
No,
10 foot head on a
the
pump,
head is the storage tank and the vertical height, right?
yeah. If I had a 10 foot head on my pump, that means I have to have a pump that can pump water 10 feet high.
No, it would mean your storage tank is 10 foot high, and that is the pressure that you gain at the bottom because there is 10-foot head of pressure. The head is 10 foot of a tank above the bottom end of the water, right? It's the pressure that you have 10 foot away from the head of the pressure, right?
Yeah, there's 10 feet of head pressure, but that determines how much the pump has to work to pump water up that 10 feet.
What?
So
No.
you're saying,
You measure the pressure, right? You
but you
don't.
calculate it
Yeah, dude. Why do you always have to calculate something first? Like,
because
surely you
that's just how
only
it's done.
know the head of pressure that you have if you know the vertical distance. You can't calculate what head of pressure you have.
Yeah, you can. It's super simple. It's rho. It's
Oh.
the head equals rho gh. It's not very complicated. It's a pretty simple calculation. Like you
So
could do this.
what?
You could do this in
Go
your
on
own
then.
home, Bev.
Give us an actual number when you actually do this to measure. If you say have 33 feet head, what's the pressure that you have? What's the on average? Give us an example of a pressure reading and a head of water pressure. What sort of pressure should we expect at a head of, say, 33 feet?
Give me 1 second to do the math. I'll be right back.
Do you not know, right? Because you've been doing this. This is you said you're doing it round the town. You're working the
Yeah,
head of pressure, so you surely must know. You must have been looking at it on your gauges.
Well, Bev? I imagine you want SI units. Okay, I don't work in SI units.
I know I didn't say any unit. You could have told me what unit you worked in.
1 second.
This doesn't sound hard for somebody who seems to be working with it. Should be just giving us these numbers or whatever, spieling them off.
Well, I don't do the shit in my head, Bev. I write it down on paper.
Yeah, but what was it? Give us the last number. The last time I can remember looking at my pressure gauge reading thing, it was 101 kilopascals. And,
oh God, I don't remember.
And that meant that I had, I don't know. I mean, I don't even know. Come on, give us some numbers. I mean, how much of head of pressure gives you what sort of a pressure reading?
Do you have any idea how many numbers I work with?
Well,
if
you are doing water pressure, I would have thought you should have had an idea on what sort of pressure you'd be expecting to find. Because, I mean, these are standard numbers, aren't they? Just a vertical.
Yeah, they're all different, Bev.
Column.
There's no standard number. They're all different.
What? It's just the vertical height. That's the only thing that matters, isn't it?
Yeah. Yes. If you shut up for a second, I'll give you the number. Hold on. I can't calculate
How
numbers
can they all
and talk to you at the
differ?
same time. Bev, they're all different.
It's
They're
water,
all different, buddy.
isn't it? Or are you pumping shit or gold or mercury or something different than water? Cleary would be interested in this, I bet. 2021. Hydrostatic pressure. Dark horse. Are you calculating? If you're calculating, can you calculate 33 feet, please?
Yeah, 1 second.
Did you expect to get this tonight, 50? I mean, you seem to have sobered up. Jeez, how long have we been going here?
Hold on, my daughter's fucking with me.
Nearly 3
Hi,
hours.
I'm back. Can you guys hear me?
Yeah.
a filing hole.
I forgot what you're doing now, 50. I don't know. Were you drawing something or... Oh no, you were doing a calculation for us, weren't you? What you gonna give us it in? What's your unit? What's your standard unit that you normally use? Kilopascals. What about millibars? Is that about too fine, that? I don't know what sort of levels you're normally working at. Bar?
Did I get kicked out or something?
No, you're still here.
No, I wasn't here.
Well, you're not? Discord does some weird
Like,
shit.
where'd it go? And then I look and it says join voice. I was like, thought I was in there.
What about PSI 50? No? Kilograms. Centimetre squared, is that? Or I don't know. How's pressure work? It's got to be squared, hasn't it? Area. They don't bother with volume, do they? It's just the column, vertical column, yes. So it would just be kilogram centimetre squared. Or... oh, that's ounces per inch squared. Or there is millimeters of mercury. What sort of inches of mercury as well? Inches. Oh, feet of 8. Oh, there you go. I bet it's that, isn't it? Feet of water. It'd have to be, wouldn't it? I would imagine. I would imagine he'd come back. If he's working head of pressure, it'd be feet of H2O, won't it? Or centimetres of H2O. Or inches of H2O.
Hold on, I'm almost done. My daughter's trying to get me to help her do something.
Because I reckon.
So I think it's about 1,000 pascals or or 10 kilopascals.
Thousands of pascals. Is that what you're normally working? For your head of water pressure, is it? With your, is it an engineering firm, did you say?
100 pascals. But I'll be honest, like I don't do this on scratch paper a lot. I do this in software.
You just do the software, did you say?
Like these units get kind of funky.
Right, so you don't actually, when you said earlier that you and your engineering firm go round the town sorting out the head of water pressure.
Kilopascals.
Yeah, your mic's gone. Are you turning round? Something. Kilopascals. You don't work in feet of H2O.
We're 14.7 psi. So yeah, that's right.
You work at 14.7 psi.
So it's equal to 1 atmosphere. So yeah, that's right.
14.7
But the
psi.
units are a little funny whenever you do conversions like this. You have
Did
to use these weird conversions. Sometimes you get like, I don't know. You have to be an engineer, work with units a lot to know what I'm talking about. But sometimes whenever you do these calculations, you don't come out with the like psi or kilopascals.
did you
come
say
out with something that's, like, really kind of
14.7
odd.
psi?
And then you have to go back and you have to do these weird conversions.
Because you've not actually given us a head yet of pressure. I mean, like,
But yeah. So I'm about 99%. That's certain because, like I said,
you're
33 feet
99% certain
is
of what?
typically. Now that I think about it, is what a dive. That's an atmosphere, right? When you're diving,
What
every
is?
33 feet you go down is one atmosphere.
All right. Okay. Yeah.
Anyways, I'm gonna finish helping my daughter. I'm gonna get off here.
Okay. Okay.
Nice bullshitting with you guys.
Okay.
Who
Anytime.
was the guy earlier that was like, "A force isn't real"? Who was that?
We can do. We can come back and explain this water pressure thing with us if you want.
Oh shit! I'm
30,
sorry.
33
I didn't
feet.
have you on. Hold on, I didn't have you on speaker. What were you saying?
I said like you should really come back to do this water pressure head of water pressure thing again, because
Well, I just did it.
what you said it
Wrote
you worked
GH.
it to 14.7
Well,
psi.
roughly. Well, it wasn't 14.7 exactly.
Not exactly, no. So that is what. That's how much pressure you normally have for your head of water. Okay.
I got 14.5. Okay. But like I said, I usually use software. It's been a while since I do like scratch pad stuff like this. So, but that sounds right. Let me check. Hold on, because now that I figured I calculated that, that makes me think of that every 33 feet is 1 atmosphere of pressure for divers. So let me double check that. Hold on.
Yeah, because psi is pounds per square inch. Right, that's a square. That's an area, isn't it?
Yes.
It's just a vertical column, then, isn't it? Because it's a square.
Well, the head would just be the 33 feet.
The vertical distance between the top and the bottom.
Yeah.
Yeah.
So that would be the head. I thought you wanted the pressure.
Yeah, so the only way you could actually measure that 33 feet over whatever distance, say a mile or two, would be to have 2 horizontal planes, one at the top and one at the bottom, and you could measure the 33 feet in between those 2 horizontal planes, right?
No. If you have a pipe that's a mile long, and there's some it's not perfectly going around the arc of the Earth, and then at the end you have a pump that has a head that we believe is 30 feet. It could be more than that, or it could be less than that, because there's no perfect thing in the real world. So that's why you use the equipotential.
It could be more or less. Did you just say?
What?
Did you just say it could be more or less?
Yeah.
At the other end?
Yeah.
Right. And are you going to hazard a guess on whether it... Because, more or less means it's not...
Yes.
It's not even. It's not equal. It's more or less, not even.
Equal?
Yeah.
Well, okay. What a silly thing to get hung up on. Yeah, okay, more or less or equal, whatever. But anyways,
more or less or equal.
Yeah.
Do you not think it would equal out, though, the water? Of its own accord?
No, not in a pumping system where you're doing plumbing for a city. It's not going to equal out. You have machines pumping water in all kinds of different directions, valves.
Is it not? You
inlet,
sure
outlet.
it's not based on the head of water pressure?
Head's part of it, but I'm saying to determine the head. sometimes we use the equipotential surface.
Did they not just establish the head with the water tower? No? I mean, that is what you do with your engineering company, right? Oh. Has he gone to go and see his daughter? It's right, isn't it, Clary? The head of water pressure is established by the header tank. I mean, that's why it's called a header tank. They normally call them water towers for establishing the head of water pressure for a city or sort of stuff. Been good chatting. 50. 3 hours. 3 minutes. 33 seconds. I'll stop recording.
Like water. Now you put water into a cup, it becomes the cup. You put water into a bottle, it becomes the bottle. You put in a teapot, it becomes the teapot. Now water can flow, or it can crash. Be water, my friend. Be water, my friend. Now you put water into a cup, you put water into a cup, it becomes the cup. You put water into a bottle, it becomes the bottle. You put in a teapot, it becomes the teapot. Now water can flow, or it can crash, Be water, my friend, water. Like water. Now you put water into a cup, it becomes the cup. You put water into a bottle, it becomes the bottle. You put in a teapot, it becomes the teapot. Now water can flow, or it can crash.